Thank you, sir. Now I request Engineer R. Jayagopal, Secretary, ING, IABSE, Karnataka Center, to welcome the gathering.
Dear engineers, civil engineers particular, my sincere thanks to the principal, Professor Ashwath of Bangalore Institute of Technology, who has consented to offer the location along with his students also to gather more information about the software and my thanks to Professor Puttegoda, Mallikarjun, in the cooperation they extended towards this workshop. The ING IABSE Karnataka Center is quite active in organizing technical seminars, but further going backwards, the ING IABSE is an offshoot of IABSE, which holds normally about 2 to 3 programs throughout the world. The present program, the immediate future program is in the Tokyo. That's about 4 days program, looking into the bridges and the structures both. The ING is Indian National Group, is quite active in organizing technical seminars, workshops, and other such similar events. Last time it was in NGO Hall, Kaban Park, wherein we dwelt with the IRC 78, Part 2 regarding the limit state designs, probably one of the most important aspects which we intend to introduce from the B3 Committee of Indian Roads Congress. With the introduction of that limit state design, it is expected to save the bridge cost, especially the foundation cost, to the extent of about 20 to 25%. And not only that, in addition to that, we will be in par with the European Union as far as the designs are concerned. My sincere thanks to Engineer Nagesh, Mr. Mohan, Mr. Arvind Salecha in organizing this workshop. The attendees here are from all cross-sections of the structural engineering, from government departments, educational institutions, private sector. This hands-on training is intended towards getting acquainted with the software, which was not familiar earlier, like your Midas, Studal, STAD, or such softwares. Certain portions of today's software are much sophisticated and with higher potential of results expected, which will be explained by the software developer here. Mr. Shishir is already here, who will help us in solving or sorting out the problems in case we come across, and this is a hands-on experience. Since the developers are here only, we should utilize to our fullest extent possible. In addition, we have in the afternoon also Mr. Jain. Mr. Jain, I consider as an interface between the software and us. So that interface is very much important because it is like a plug. You put a plug and we receive whatever the power required. And all our doubts, whenever they ask questions, whenever they ask any doubts, I expect our audience, at least each should ask one question. Each. He should get fed up. That much of response we should give so that whatever doubts we have must get sorted out. In the meanwhile, the major problem with our designers is the usage of pirated versions. This is a very serious issue in the software which is unacceptable in the private sector as well as in the government sector. We are already verifying, as far as these pirated versions are concerned, we are already verifying the original softwares. In fact, only yesterday I asked our slumboard engineer to gather information about the softwares that have been used and their official versions to be submitted. So that way, I request the government departments also here, or the owners of the private also, to verify the softwares used, whether they are the original or the pirated, so that you are encouraging the original man, plus in case something going wrong with a pirated version, that cannot be repaired afterwards. Engineers are encouraged to use licensed versions of software so that accuracy and originality is maintained. Best wishes to everybody here, and kindly gather as much information as possible. In fact, this is being live streamed here. Live streamed. In fact, yesterday evening I have already sent the link to our headquarters, is IABSE Delhi. And I requested them also to send it to all the members throughout the country so that everybody can see from the headquarters also. So this is being live streamed. Probably after about 10-15 minutes, you can get the link from there and pass it on to your officers also, so that from the office they can have a look at this. In fact, same thing happened in 2 of our earlier programs. They are very happy, including their residences. Thank you very much for attending. Thank you, sir, for your cooperation here.
Thank you, Mr. Jayagopal, sir. Now it is my duty to formally welcome our guest on the dais. I request Arvind Salecha to welcome Professor M.U. Ashwath, principal of this college, and who has been encouraging such programs for this wonderful program. I request Engineer Mohan to kindly present a bouquet to Jayaprasad, sir. Welcome you, sir. I request Jayagopal, sir, to present a bouquet to Professor and HOD Sri Puttagowda, sir. I request Engineer Taranath to kindly present a bouquet to the most important person of today's program, Shir, from Sophistic. And most importantly, the energy behind such programs is our Mr. Jayagopal. I request Arvind to present a bouquet to him and welcome him. I request Professor Ashwath to kindly give his inaugural address.
Good morning, and I'm very happy and excited to have all of you at Bangalore Institute of Technology. And in fact, from last 20 years, BIT is supporting the industry, and we have been conducting a lot of programs. Many hands-on workshops also conducted in BIT. I'm actively involved in the Association of Consulting Civil Engineers. I was the president of that association. I was also vice president of Indian Concrete Institute. So my connection with the industry and the practicing engineers is much. And we normally conduct almost all programs of these associations. We usually have in our Ramegowda Seminar Hall, which accommodates about 250 capacity. Every month we used to have evening technical lectures from 6 to 8:30. Normally, whenever experts come from other states, other countries, definitely we will have one program here at BIT. So that is the background, and I'm very happy. And connected to bridges also, we have done a lot of programs. We have done one program of maintenance of all bridges in association with Institution of Engineers, and with respect to Bangalore, all the maintenance of flyovers and other things, we did some work along with BBMP and BDA. So I'm very happy. I'm in touch with most of the consultants here. And we have also brought out one very useful handbook for the task force of Government of Karnataka. I edited that book under the chairmanship of Dr. C.S. Vishwanatha. It's about 500 pages document which is freely available to download from the PWD website. You can all download that and you can use it. About 35 top consultants have contributed to prepare that handbook for practicing civil engineers. So I will not take much time. Please practice the software and see the nuances of using the software effectively with the developer and the consultants who are already practicing. It will be very useful. And in future also, we welcome all of you to visit BIT whenever you need any support from our organizations. You are also free to use our library. We have a huge library. We are a member of journals consortium. We get more than 1,000 journals. You can come here and use it freely. We open to all of you, and any support, BIT is always there. Thank you very much. I will not take much time. Thank you.
Thank you, Professor Ashwath, for your encouraging words. And you have been constantly encouraging such programs. And we thank you and BIT for this wonderful encouragement. I recognize the presence of Repaka Srinivasa, Chief Engineer, BMRCL. Welcome, you, sir. Now I request Sri Jayaprasad sir to say a few words on this program.
ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. Our sincere thanks to the management of Bangalore Institute of Technology to hold this software training program for benefit of engineers in the state. Actually, Mr. Jay Gopal sent me a message saying that the BIT and the principal has been very, very active and they were very positive. Sir, today what we lack is positive mind. ಯಾರಾದರೂ ಏನಾದರೂ ಕೇಳಿದ್ರೆ ಗೊತ್ತಿಲ್ಲ ಇಲ್ಲ ಇದೇ ಜಾಸ್ತಿ ನಮ್ಮಲ್ಲಿ. ಅಂಥದ್ರಲ್ಲಿ ನೀವು ನಮಗೆ ಸಹಾಯ ಮಾಡೋಕ್ಕೆ ಒಪ್ಕೊಂಡ್ರಲ್ಲ, ಅದಕ್ಕೆ ನಮ್ಮೆಲ್ಲರ ವಂದನೆಗಳು. Our thanks and appreciation to the participant, more so from neighboring state of Andhra, Anantapur. I hope they are here or on the way. Thank you. Thank you. They have been with us for all our workshops and programs. Thanks are due to all of you. Without you, this room would have been empty and there was nothing for training and we should have simply cancelled our program. So I thank each one of you for actively participating, and I hope you will pick up fineness and better knowledge from this workshop. ನಿಜ ಹೇಳಿದ್ರೆ ನಿಜ ಅಲ್ಲ, ಇರೋದು ಹೇಳಿದ್ರೆ during our time there was no calculator. Now we used to go for logarithm, 4-figure, 8-figure tables. Our foreign exchange increased from 2000. Early Virgo, we didn't have that foreign exchange reserve. Thanks are due to our giants in the software industry who have brought our country to this stage. IABSE is an international association of brick and structural engineers created in the year 1929. It's almost nearing 100 years. With headquarters at Zurich, Switzerland, the MOTH has a center of IABSE operating from Delhi. The function of this association is disseminate the technical knowledge. This is what is lacking in, particularly with engineers. What you know, I don't know. What I know, you don't know. We don't exchange. Definitely, it is a rather leg pulling. We are lacking in everything, more so in exchange of thoughts. Particularly, every senior in every institution should guide his juniors. Now, time illa, ankedu, even kedu, go to next room, like that. Unless we exchange our knowledge, we will not improve. This workshop is for that. Whatever knowledge the two speakers are there, it is they are disseminating their knowledge, spreading their knowledge. This hands-on training session from Sophistic software company and a parametric modeling by Mr. Pratik Jain is intended toward dissemination of software knowledge in design of bridges and buildings. To mention, Rajiv Gandhi, where I am associated, has built 14-story high-rise building with monolithic methodology and aluminum shuttering. It is very, very quick and faster. The more shuttering you have, the more. If you have 20 shuttering, you can build 10 units in a day. That's the record you have. And no finishing is required, just putty and painting. This, I will tell you, way back in 1965, the Vishwesvaraya Tower, it is called Vishwesvaraya Tower because Sir Ami lived there in the government quarters opposite Coffee Boat building, where they have built 20-story high-rise building. Then again, coming back to city corporation, somewhere in 60s, they have built on pile foundation, public utility building, 18 floors high. What we are doing today is nothing compared to what they have done, what our elders have done. So, sir, the government sector as well as private sector are engaged in the construction activity wherein the software can be utilized to its fullest extent. Today in the morning newspaper, I saw that Banglore is the 4th in the estate development in the whole world. They are behind Dubai and leading over Mumbai. I wish your training, your day is well spent. Thank you.
Thank you for your very encouraging words, sir. I now request Professor Puttegoda to say a few words, sir. Now I request Engineer Arvind Salecha to say a few words on the latest software, adopting the same in our designs and analysis.
Thank you, sir. Namaskara, good morning. See, I think in 2020-21, IABSE, Indian Association of Structural Engineers, they had organized a online webinar. Okay, that was totally conducted by international experts. I mean, one thing what caught my attention was a software engineer from Norway. He designed and had a bridge constructed in Norway. Not a civil engineer, a software engineer. And that too, he got it done without any drawings. And when he presented it, he said, why should I design? So many softwares are available for the design. Softwares are available for preparation of drawings. What is needed is how to integrate or automate these things. That is what that guy did. He had basically developed a Python program to integrate these things. The only thing where civil engineering came in was he got the designs and drawings vetted by reputed civil engineers. And no drawings were prepared, in the sense no hard copies were given. At site also people were using the tabs, and using the tab they did the entire construction. Then it was like, wow, why can't we have it done in India? And then I started looking into how, we can automate. All of us, we are using STAD, MIDAS and all. We use that for design, for modeling, analysis. We take out the results. Maybe some of us use Excel to do the design part and all. And then we use AutoCAD or any other ProGCAD or something to do the drawings and all. But they are still not integrated. And one more thing is that you have designed a building or a bridge, say maybe a 4-girder system, 30 meter span, we have done it. Now, tomorrow I need to build for some other project a 6-girder system, a 40 meter span. Again, we are starting from zero, We are starting the modeling from zero and all. So this is where what happened is around 2 years back, my friend Pratik Jain will be presenting today afternoon. So he contacted me. He told me there's a webinar on Sophistic that he is preparing. He is presenting rather. So that was on parametric modeling. That you have done one design, just change the parameters, you get your next design ready. Why do you start from zero? So that he'll be starting in the afternoon he'll be presenting. So that is how we came to know that there is a software called Sophistic. And then when Jai Prasad sir and Jai Gopal sir said, from ING, IABSE, we should have a program and not just a normal seminar where people, just come, attend some seminars, they attend part of it, they don't attend part, just have lunch and go away. We wanted to have some proper hands-on training so that people who come here, they really learn something. And hence we contacted Sophistic, and I'm thankful that Shishir and Saheli are here. So they'll be, we are thankful to Professor Ashwath because we have got this wonderful lab where the software is already installed on the system, so that once they are presenting here and all, any program and you can, problems and all, you can solve there. So you'll have a practical hands-on training. So that was what was needed, and I thank ING, IABSE. I mean, you have taken a wonderful initiative to start this, and let's, going forward, let's do more such programs. Thank you so much.
Thank you, Arvind. Just to add a few more things to what Arvind has told. See, as you know very well, our country is witnessing a huge construction, both in infrastructure as well as in buildings. So we have been witnessing construction of long elevated roads and long bridges along the waterways, ceilings, okay, and many flyovers, bridges across the national highways and state highways. And we also have a lot of projects in irrigation, aqueducts, elevated, okay. And we also are witness to what is known as the construction of 40 to 50-story building in our metro cities, particularly in places like Banglore, Hyderabad. Of course, Hyderabad is a little ahead of Banglore in terms of number of floors. And all metro cities are observing such a huge construction even in building. Earlier, a size of 20-30 crore project was rare when we started our engineering. Today, a 500 to 1,000 crore project, whether it is in the government sector or in private sector, is very, very common. So, what does it mean? It poses a challenge to the design engineers. Because ultimately, it has to pass through the hands of the civil engineers or design engineers. What do we expect of the design engineers? First and the foremost thing, yes, I agree to Arvind regarding automation, all those things. The most important thing is you must have the fundamental knowledge to understand the behavior of any structure. Once you know the behavior of the structure, it becomes very easy for you to understand the software and effectiveness of using the software. That is part number one. Part number two, how to handle such large size projects. Today I'll tell my engineer, Bob, I don't know, tomorrow I want a 40 meter span bridge design. Because that is the deadline I am given. People approach us, Sir, I don't know, I want in 2 days, I want yesterday. How to rise to the occasion? So, see, already my engineer is smiling at me. So that is the kind of pressure we are all having. So to answer that, only thing is we have to depend on softwares, which are very, very good tools. But we must know how to operate that, and we must know its features, and we must also know what are the drawbacks. Both are very important. A good software is one which has ease of modeling and quick computation and accurate analysis, and also complying to the codes, the codes of our country or any other place in terms of design. Because there are softwares which say they have a design package, but it is all conforming to American standards or British standards. But for our current scenario, we also need the software whose design modules are compliant to our current codes. Okay, we have been using many software. Started with the STAD. STAD is a very popular one. Then we have Midas. We have got CSA Bridge. So many softwares we have been using. Okay, and we are looking at some other softwares also, which are going to be much more friendly and most importantly, most cost effective. That is very important. Okay, because way back in about 20 years back, right. So I purchased Midas almost 20 years back. I paid 7 lakhs that time. 7 lakhs that time. Of course, the company was a little kind enough to give me in installments of 3 or 4 installments. But still, that was a huge amount. Now, with so many users in the field, I am sure they can capture the market, they can be cost effective, and I am sure technically they are going to be very good software which they are going to present. Okay. Now, for today, the software has been installed in all these computers, and after that, they are going to give a link to all of you. You can use it for a couple of weeks and give your feedback to them, because your feedback is very important. So as told earlier, it is just not somebody coming, giving a lecture and going on. Here we are going to have a hands-on experience of using a software. Please make complete use of this opportunity and explore the possibility of using such software. Thank you. I now request Sishir to say a few words.
Thank you, firstly, to all because of whom this event has been possible. Since I have a lot to speak throughout the day, I would say that let's get started in a few minutes without much ado. And only one thing I would request is, if you have any questions, if you have any queries related to, need not be related to the software, if anything technical as well you want to discuss, please feel free to raise that concern. I myself, if I'm allowed to introduce myself right now, okay. I did my bachelor's from IIT Roorkee. I'm a pass out of 2012. And I did my master's in finite element analysis from École des Ponts, Paris Tech, France. And post that, I have worked in consultancy for a couple of years, bridge design consultancy to be precise. And after that, I joined Midas in South Korea, working in the consultancy and the development team over there. So I have this international experience of about 10 years, after which I moved back to India in 2019, October. And I've been working with Midas for a couple of more years during the pandemic. And post-pandemic, since I had used Sophistic earlier in Germany during my master's, I contacted them and I have joined them since January 2023. Yeah, that's 2.5 years. And throughout my experience, I have the experience of working in various projects, and I have assisted. The major service of Sophistic I can highlight is the first project consultants. So this consultancy assistance which Sophistic offers is basically where we work with the consultants to complete their project from start to end. That way, new users of Sophistic get accustomed with the interface as well as they understand the whole workflow, and they also gain confidence in their results as well. Because most of the times it has been the case that consultants have chosen some high-end projects. So I have worked on cable state projects like, you can look at the Mahalakshmi cable state project, it's under construction, Marsova cable state project. Then I worked on suspension bridge as well for Gujarat. And then there are several medium-sized projects as well where we discussed about automating the repetitive bridges like composite bridges, post-tension composite bridges, as well as steel composite. So I have a mix of all these bridge design experiences. Yes, I'll be highlighting all the capabilities of Sophistic through my presentation, but the hands-on experience that we are going to have will be on a composite bridge, and like it has already been discussed that we need to save time on automation, and automation being one of the strengths of Sophistic. So we'll be having a hands-on experience on automating the repetitive bridges. To be precise, we are going to discuss on the PSC composite bridge. So I think that's about the overview of what we are going to have today. And again, I would request any questions, please just raise your hand. If I'm unable to assist you, I have my colleague over here, Ms. Saili Kulkarni. She manages the sales and operations of Sophistic in Central and Southern India. So she is here to assist us. She'll be assisting throughout the day for the workshop. And just raise your hand and we'll be there at your seat to help you. All right, thank you.
Thank you, Sushir. As clearly informed by Sushir, followed by this inaugural session, we have a hands-on training program in the first session. And then there will be a small lunch break. Then again, there will be a talk on this parametric modeling by Pratik Jain. And also, you can have some interaction with Sushir and his team and make complete use of it. Now, with this, we are almost coming to the end of this inaugural session. I request Engineer Mohan to propose vote of thanks.
Thank you, sir. Ellarigu namaskara. At the outset, I thank the dignitaries on the dais for having inaugurated the workshop, and also I thank all the delegates who have come over here. First thing what I have to say is, I thank the principal and all the management of the BIT for being so very positive, and they have given a very good hospitality in hosting this workshop to us. Secondly, I thank the Sophistic management for having accepting our invitation to host, to give a good very seminar over here. I thank them. And when I met the department engineers, they were so enthusiastic. And in fact, I spoke to Jai Gopal. Sir, the number is getting increased. It may go over for 70 or so. He said, no problem, we will arrange it. So I thank Jai Gopal also. And lastly, this IABSE. I thank the IABSE, all the members and the president also for hosting this session. One thing what I have to say is, when they were arranging it, one point came, so what should be the fees? Our chairman and our Jai Gopal sir said, so no fees. So what the important thing the IABSE is organizing it, whatever the latest technical know-how is there, that should be disseminated down the lane to the engineers, to the professional consultant, all those people. In that way, IABSE is taking a very positive lead, and they have also conducted so many programs. I thank Professor B.V. Nagesh. So in fact, when the point came where to arrange this, where to have the all the computers and all those things, he positively said, sir, we will approach the BIT, and the professor easily accepted. I thank you. I thank you all. One thing, as Professor Nagesh said, whatever it is, as an engineer, you should know the basics. No doubt you have the Sophistic software, you are going to utilize it, and what it is, what it has come out, the results, what has come out, you should be able to judge it, whether it is right or not. In our days, when we were in the designs, we started with Guha software, then we came for STAD, then for ETAP, then Midas. I have not used this. So you're all young engineers and professional engineers. Utilize this opportunity, and wish you all, thank you all.
Thank you all. Let's have a 10 minutes coffee break. then we reassemble for the training program. Thank you all.
Is it audible? Volume कम करना है. Is it loud enough? ज़्यादा loud हो रहा है? I think it's okay. आवाज़ जा रही है ना? नहीं आ रही है? ठीक है. और ऊपर करूं? Hello, is it audible? Hello, hello.
All are requested to take your seats. Let us commence the program. Hope you had tea and snacks. And in case you don't get the seat, in between seats also kindly make your own arrangement so that everybody can be accommodated in the hall. With this, Mr. Shishir Kumar, you can start the introduction and please commence and go ahead.
Any light? Good morning, everyone. Am I audible at the back? Thank you. I hope everyone has got our catalogs. We have shared it just for an overview of Sophistic software. Though I'll be giving an overview through my presentation over here before we actually get started with the hands-on experience on Sophistic. All these systems have the software installed. So in case you're having any problem or you just want to check, you might have. Is there a problem if I move along? उसको ऑफ कर दीजिए. Okay, thank you. Yeah, it's working. Okay, so first thing first, since it's a hands-on experience you're going to have, you have Sophistic installed on your systems. Please just look at your desktop and you'll find SSD and Sophistic Application Manager on the desktop of the computer you are sitting on. SSD and Sophistic Application Manager. Just make sure that SSD shortcut is there. As long as Sophistic is installed, there should be a shortcut at your desktop. If it isn't, please inform our IT person or my colleague, Saili over here, and we can help you get it installed. In the time I'm presenting, the installation will be completed so that we won't have any stoppages during the workshop. I'll guide you for the license activation once we are done with the presentation. So let's get started. I have already introduced myself, so these bright lights might not help seeing the presentation slide, so maybe we can switch it off once we are done taking the snaps. Alright, so we'll go to the next slide. Thank you. So this is what we are going to cover in the presentation. Firstly, I'll be starting with the company introduction and give an overview of Sophistic as a software. And Sophistic, as you must have seen from the catalog, it's capable of handling bridges, buildings, detailed finite element analysis, geotechnical, as well as we are quite powerful in BIM because Sophistic and Autodesk are partners. So we are 100% integrated with Revit for that purpose, whether it be building or bridges. So I'll mention that capability as well. There was a talk regarding the cost efficient part as well. So we do have license configuration and services to be talked about. And then we'll start the hands-on workshop. So let me start with the company introduction. As you can see over here, Sophistic is not a new software company. It all started as a PhD project. So it was a PhD project in TU Munich, Technical University of Munich. And it got registered as a company in the year 1987. That PhD student and the professor happened to be our director. And they are retired now. Since the very beginning, Sophistic has a text-based interface. And the graphical interface of Sophistic came into picture when Sophistic partnered with Autodesk. So it was in the 1996 that Sophistic and Autodesk partnered with each other, and that is why we use AutoCAD for modeling, property definition, boundary definition, load application, pre-stressing. Everything that we do in the pre-processing part is to be done in AutoCAD. So if you are familiar with AutoCAD, you already know the graphical interface of Sophistic. We don't have much to teach you for the graphical interface of the software as such. But even if you are unfamiliar with AutoCAD, there is not much of the CAD features that we have to use. We'll see in today's workshop how we can utilize it to our advantage. Moving on. Here is the history of Sophistic. Though incorporated in the year 1987, the major idea of expanding Sophistic around the globe began in the year 2012. So since 2012, every 2 or 3 years, a new branch office or a subsidiary of Sophistic has been opening. And though Sophistic decided to have its office in 2019, but due to pandemic, it was delayed. And finally, in January 2023, Sophistic India got registered. So seeing by the registration date of Sophistic over here, you might see that it's a company which is having new usage in India, but that's not the case. If you look at the partial list of Sophistic users over here, global companies like Covey, Ramboll have been using it over 2 decades. Spectrum, which happens to be a quite big design consultancy in Navi Mumbai, they have been using Sophistic for over 15 years, from whom we have Pratik today as a speaker in the second half. His company has been using Sophistic for a decade now, and we have other organizations as well amongst the national companies. We have educational institutes as well, like IIT Delhi, IIT Roorkee also uses, haven't mentioned it here, IIT Bombay, VNIT Nagpur, and we have government organizations like PWD Kerala, PWD Navi Mumbai, as well as in railways, we have Western Railway, Central Railway using Sophistic software. For all the 2 years time since the incorporation, we have got 85 plus users in India. So we are rapidly growing. The reason behind that, I would say, is majorly the technical advantage of Sophistic over other prevailing software. So whichever software you are using, feel free to ask me questions that, okay, this is how we do it in the software I'm using. Can you try to relate it? I'll try my best to relate it and help you understand. Maybe that can help you understand the software even better. Let's move on to the partial list of global users of Sophistic. So it's a partial list across the world, and I'll move on to the product overview now. So as I mentioned, Sophistic is capable of handling all types of bridges, buildings, even the tensile membrane structures. So membrane structures where the form finding of fabric is required, that kind of analysis and optimization of the tensile membrane can also be done in Sophistic. We have applications in general structures. General, by that we mean combination of concrete, steel or timber as well. BIM, we are quite powerful and has been used over a decade in the European countries, especially because since we are partners with Autodesk, Revit is an Autodesk program and we are fully integrated with Revit. So anything that you create in Sophistic can be fully exported to Revit. Need not be firstly created in Revit. You can create it in Sophistic and then you can export it to Revit for the draftsman or the BIM engineer to prepare the drawings from there. And then while the engineers can work on analysis and design in Sophistic, the drawings can be extracted from Revit itself. Now, Salecha sir mentioned that he observed some paperless construction. That's a term that comes when we are constructing on site without referring to drawings. But in India, we feel at least a decade, if not more, for us to move from 2D drawings to 3D drawings and then from 3D to paperless construction. So paperless construction is something that is being utilized in Europe, and the reason why Sophistic proves to be quite powerful in that is because Sophistic is fully integrated with BIM softwares like Revit and Tekla. So anything you are creating in Sophistic is dynamically linked with programs like Tekla, and that Tekla itself is being used for construction on site with the screens mentioning the rebar detailing, and that is being observed whether in tab or a big screen that is being placed on site for the construction. So that is the approach. Probably that's the future which we will head on to, but we feel at least 10 years down the line. All right. Furthermore, Sophistic has detailed finite element analysis also very well supported. So if we are looking for crack propagation analysis or steel nonlinear analysis, say we want to consider the nonlinearity of steel using von Mises Tresca material models, or we are interested in, let's say, masonry structures, or we want to go for the solid modeling, then those types of detailed nonlinear finite element analysis can also be done in Sophistic. And as you can see, geotechnical is also within the scope of Sophistic. So for geotechnical, Sophistic doesn't compete with major geotechnical programs. I'm sure if you work with geotechnical consultancies, Plexus and other programs are quite good. Sophistic meets the structure engineers' geotechnical requirement in terms of excavation analysis, slope stability analysis, foundation analysis, soil structure interaction. So those aspects are very well covered within Sophistic. So having the structure modeled along with the soil and then analysis and design of the structure itself from that interface, and all of this within the same software. Sophistic is a modular software. It has modules for modeling, modules for loading, modules for analysis, load combinations, design, report preparation. So there are separate modules that we'll be using. And this is an important slide. It's about the workflow. So I'll talk about the workflow first. SSD, you already have the shortcut of SSD on your desktop. SSD stands for Sophistic Structural Desktop. So this is the starting point of Sophistic. From this, we can go to the graphical interface of Sophistic. And as I mentioned, we use AutoCAD for modeling property, boundary loading, pre-stressing. As an alternative to AutoCAD, when we deal with organizations, they say that, okay, we don't want to give AutoCAD license, for 3D AutoCAD license to engineers. We just give AutoCAD LT. So that will not suffice, of course, for 3D modeling. That's why Autodesk has developed an alternative to that. It is an Autodesk product. It's a perpetual AutoCAD. So instead of naming it AutoCAD, we have named it Sophi Plus X. It's an exclusive software, and Sophistic holds the right to sell it. It's a perpetual AutoCAD license. So in today's workshop, in all these systems, we have Sophi Plus X installed. So we'll use Sophi Plus X from modeling to for entire pre-processing work, and then we'll export the model from there to SSD and analyze and design here. Whatever you are modeling here, it's a bidirectional link with Revit. You can export the model to Revit and do the BIM part. When we are using CAD, there are two ways of majorly working in CAD mentioned over here. So one is GAD based approach. Whenever we are starting a project, we must be having a GAD. If we have the GAD available with us, we can care of our importance and use those layers to construct our geometry. That is primarily the GAD based approach which Sophistic supports. We support it and it can be utilized for various projects. However, the other approach, which is access-based modeling, is what we are going to discuss today. Hello? Access-based modeling is something that we are going to discuss today in the workshop. So the difference between GAD-based and access-based is, in case of GAD-based approach, we are copying the AutoCAD GAD which your draftsman might have prepared, using that as a reference to create our geometry. However, in the access-based approach, we create an axis, we create placements. We will be doing it today. We'll assign the entire geometry boundary loading to these axes and placements. If I rotate the axis, the entire superstructure rotates. If I move the placement inside, the substructure moves along with the placement. The girder length gets shortened, tendon length gets shortened. So full control of geometry using the axis and placements. This makes it possible. Say it was mentioned that we have already modeled a 40-meter composite bridge model, and now we get another project, or let's say there are the same now. You have to make changes. It will hardly take you 5 to 10 minutes to have a new model with everything changed to from 40 meters. Let's say you want to have 32-meter bridge, everything will be changed within 5 to 10 minutes. So that is the level of automation that you can have with the access-based modeling approach, and this is what we'll be covering in the hands-on experience today. Enough said about the graphical interface. Sophistic has the text interface as well. We won't be touching upon the text interface today. Text interface is popularly known as TEDdy. You might be seeing the shortcut of TEDdy as well on your desktop. So this is integrated with Excel for the purpose of Excel automation. So in case you are willing to explore the automation capabilities of Sophistic, instead of doing it graphically, the access-based approach, we have the Excel integration as well. So there are organizations, and I think Pratik would be in a better position to tell about that, because they have quite many automations with Excel being utilized at their organization. So how Excel automation works is, basically we give the input data in the Excel file. Sophistic in the backend reads the Excel file, performs the analysis, and sends the results back into the Excel itself. So we have developed it for other government organizations as well, and private consultants have developed it themselves. This Excel integration makes you capable of using Sophistic without actually going into Sophistic and running the analysis. So you are giving the input data in Excel. Sophistic is performing the analysis and sending the results back into your Excel. By results, I mean not just the tabular results, the graphical results as well. Let's say the loading pattern or the bending moment diagram or the stress plots, all that is dynamically linked with the software. So all you're using is the Excel. And this is being utilized for repetitive projects. When we talk about automation projects, let's say it could be for composite bridges, for box girder bridges, for steel composite, or it is being utilized for substructures as well. So this is Excel automation, and we'll see a demonstration as well of this. Now further, there are companies who are not interested in writing the text scripts as such. So for that, there is visual programming, and that is in Rhino Grasshopper. We won't be touching that for today, but certainly that is the visual interface of programming in Sophistic and fully integrated for the purpose of bridges and structures. Let's move on. I'll specifically talk about Sophistic for bridges now, and we'll highlight how Sophistic adds value for bridges. If you're a consultant who is working on bridges, I think this will be quite attractive to you, and this will answer your major question: why should we opt for Sophistic if we have other programs currently being used for bridge analysis and design? So let's start with the first part, which is automation. Automation can be done graphically as well as through text. So for graphical automation, you can see over here, this is an axis. This stores the superstructure information, and these crosshairs that we see are the placements which store the substructure information. If I move the placement inside, the substructure moves inside, tapering gets adjusted, the tendon length gets adjusted, and also, of course, the span length has been shortened. Control the whole geometry using axis and placements. If I rotate the axis, the entire superstructure will follow the axis. Superstructure as well as substructure will follow the axis alignment. So this is axis-based automation, and for your idea, this is a video that we are seeing for the axis-based automation. So it's a single span PSC composite bridge prepared by one of the Sophistic users, and you can see it's in the CAD interface that we are seeing a PSC composite bridge modeled over here. It's a line model. It has complete boundary and loading information. There are two axes defined, one for the girder, another one for the deck. Now what we are going to do over here is we are going to shorten the span length. So going to the placements of the girder, the span length is being reduced. Are these numbers visible at the back? I doubt it. No, right? So probably when we are working with the hands-on, I'll have to zoom in. If anything is visible, not visible during the workshop, please let me know so that I'll paste it in Word and make it larger. So we have reduced the span length. So you can see girder has shortened, the loads also have shortened because the deck has also been shortened. So it's a shorter span now, and it's a straight bridge. Still it's a straight bridge. Let's say I have a project of a curved skewed bridge, so I can give it a radius as well. So I go to arc, I give it a radius, and then to placements, and you can get the model generated quickly. Any questions? Yes, sir? Sorry, sir? No, girders are straight. There were two axes, sir. One for the girder, another one for... You got the answer, right? There were two separate axes, sir. One for the girder, another one for the deck. So we rotated the deck only, girders were straight. Okay, this is another automation that we prepared for one of the government organizations, CDO. Yes, sir. If the girders were to be curved, say it was a box girder, then I would not need separate axis for girder and deck. I can have a single axis, and whatever alignment I give, whatever curvature, entire geometry will follow that curvature. So that way we can make it possible. Now here we are seeing Excel automation. Like I mentioned, Excel automation is something that is being quite extensively utilized by Sophistic users for repetitive bridge projects. Again, whenever we talk about automation, it is for repetitive bridges. So Excel automation is something where, So Excel automation is something where we give the input data inside Excel, and when we usually decide what all variables are there. So number of girders can change, spacing between girders can change, span length can change. We decide these variables and take the input of those. Rest everything for the project is fixed and it is written in the backend. So whatever are the variables are to be inputted here. I'll make it quick. So whatever are the variables, we mention it over here, and say we make a change. Let's say currently if we want to see the 5 girder system, it's a 5 girder PSC composite bridge model over here. We go back to Excel, we make a change, we change it to 3 girder system and click on calculate. The calculations are performed, and now if we see the graphic, it will be a 3 girder system with everything revised. So since the geometry is getting revised, the loadings are getting revised, construction stages are fixed, and the complete analysis will be performed. So this is a 3-girder PSC composite bridge generated from the same sheet. Now here the consultant did not just want the analysis, but they wanted it for the bidding stage. So what they did was, they got the tendon profile also optimized. So they provided that, okay, we want to give multiple profiles, and software will iteratively analyze for one profile. If it is not passing, it will increase the number of profiles and then analyze again. If it is still not passing, it will keep on increasing. So maximum 4 profiles have been given over here. Maximum tensile stress limit at the bottommost fiber for the rare combination. And if this larger than this tensile stress limit, it will go on iterating and increasing the tendon profiles unless it is satisfied. If it is not passing even after all the iterations up to 4 profiles, further they had got the section optimization done. So in section optimization, the web depth will be increased at an increment. So this is an application of Excel automation. Now next I have an Excel automation from Force. So I have a video of yours, Pratik. So you had posted it and our marketing team has taken it from there, probably from LinkedIn. So this is a substructure automation. I think you'll be in a better position to present this, but here basically the number of the peer cap configuration, peer configuration, pile number of piles, spacings and all are being controlled from here. Text file is being generated. Now copy code is one approach that is being utilized here. Need not be, it's not necessary to use this copy paste approach. Sophistic directly reads the Excel file as well. However, here it has been adopted, and then we can see a substructure model getting generated. Now if we have to make changes, we can go back to Excel. Say instead of rectangular, we have changed it to inverted T section for the peer cap. Now peer is circular. We'll change the number of piles from 6 to 4, and we can generate the model file again. Performing the analysis, we'll have the new substructure model generated. There you go, we have the 4-pile configuration for the substructure. We have developed a similar automation for railway organization as well as for PWD, where they are having substructure projects, single pier, 2 pier, as well as for abutments, box type, C type. So those automations we have already developed and helped the government organizations acquire those from us and utilize it for various substructure projects. So basically these are the automation capabilities of Sophistic, and we'll move on to the last automation capability, which is through Rhino Grasshopper. Won't go much into the detail of Rhino Grasshopper at present, but yes, it is quite powerful, picking up quickly. So hopefully we'll be hearing about it soon in the industry once Rhino Grasshopper also becomes a trend for visual programming. All right, let's move on to the next part, that is BIM. Now for BIM, Sophistic is integrated with Revit, and how this integration works is, we assign the superstructure to the axis. This is the primary axis. This will have the superstructure information. Substructure is assigned to the placements, and then we extract the drawings along the axis. Wherever we define the placements, we can extract the drawings out of it along the curvature as well. So makes the drawing extraction quite easy, and we can have the IFC file export in the native Revit IFC format itself. Furthermore, this model has bidirectional link with the graphical interface of Sophistic for the purpose of analysis and design. So it works for the complete solution as long as you're using Revit for the BIM practices. And just to highlight, if you're using Revit and you're in building design industry, the major value addition Sophistic has is automatic analytical model generation. So when you're working with Revit and you're working in buildings, we have to generate an analytical model which we need for the analysis and design. Sophistic has the analytical model generator, which automatically generates the structural members from the architectural model, generates the analytical model, imports it in Sophistic, analyzes and designs. So that is the major strength of Sophistic for building industry as well in terms of integration with Revit. Now I'll go into specific bridge types. Culverts, by the way, any questions so far? Do we come across culverts quite often? Not much. Okay, I would like to see, sir. All right. Culverts. All right. Let's see what Sophistic has to offer for you if you're using culverts, or designing culverts, I should say. So for culverts, Sophistic has this Excel automation capability. Of course, from the same script, you can generate 2D model as long as its skew angle is less than 30 degrees. You would be okay with having 2D culvert models. If you want the 3D model, from the same script, 3D shell model can be generated. You'd be mostly going for it if the skew angle is more than 30 degrees. So Sophistic is capable of generating the 2D as well as 3D model from the same Excel automation script. All you have to use is the Excel file. That is the Excel automation capability, nothing else. And furthermore, the major value addition, if you are going for the 3D box culvert, there is no software in the industry which can give you 3D live load dispersion, whether it be STAD or Midas or any software that you would be knowing. No software has the capability of 3D live load dispersion. Sorry. So this 3D live load dispersion is basically dispersion of live load in the longitudinal as well and is incorporated in the scripts of Sophistic that we have. Now talking about shell model, Sophistic has the unique capability of having pre-stressing in plate elements. So if you're working with any of the softwares that have been mentioned so far, none of the software have the capability to have pre-stressing in plate elements and analyze and design those plates. So Sophistic is the only program currently having the capability to analyze and design plate elements with pre-stress. And that is the reason when you're working with full shell model, having the tendons as well as in transverse, if you have transverse PT, then full shell model requires the tendon modeling inside the plates, and that is where Sophistic has the major value addition, especially spine and wing, or as long as you have transverse PT and going for the shell model, it will become advantageous, or if you're going for the full shell, then in that case as well, it adds value. Of course, you can have the tapering simulated in Sophistic, and you can have nonlinear temperature gradient as well simulated on plate elements. Not just on beam elements, you can have it on plate elements as well in Sophistic. Let's talk about composite bridges. Enough talked about the Excel automation and the graphical automation capabilities for composite bridges. Let's talk about the approach. When you're dealing with composite bridges, how you would be modeling is you model the girders. For the transverse connection of girders, usually you might be going for the dummy elements if you're not using Sophistic, right? Now dummy elements, it's fine, you can use it in Sophistic as well for the transverse stiffness, all good. But the problem with dummy elements is, I'll take reference of one of the projects from Jaipur. I will not mention the consultant's name, but it was a steel composite bridge. Pouring was done in sequence. So first pouring was done, next pouring was done afterwards, and there was cracking observed at the interface of the shell element. This cracking cannot be obtained if we use dummy elements, because dummy elements can't give you stress at the interface of that plate. But if you're using plate elements for modeling the deck, you can identify those stresses, and accordingly you can take measures to avoid that cracking on site. So this is why we recommend the approach of having shell for the deck. Now you might ask me the question that, okay, we are having composite section here, we are having the plate as well, stiffness would be duplicated in the longitudinal direction. So Sophistic has the capability to convert an isotropic slab into orthotropic, making the longitudinal stiffness 0, having only the transverse stiffness effective. So longitudinal stiffness becomes 0, and that is how we cater to the problem of avoiding the duplicacy of stiffness in the longitudinal direction. Now furthermore, yes sir? We have to just choose the group number, sir. For which group? Say we put it in, let's say, group number 30, then we are saying that, okay, for group number 30, I don't want the longitudinal stiffness. Because in a project, there might be multiple plate elements, and you'd be interested in some of the plate elements only to have no longitudinal stiffness. So that is it. And talking about shell modeling, there is another advantage that if you're dealing with such bridges, you might be doing the transverse design yourself, separately in your Excel sheets. If you're having the shell model, for the composite bridge, you can directly have strips defined of unit width, get the forces, design it like a beam, and do the transverse design here itself. I know you'll want the dispersion to be done. So you can have the dispersed load run, and you can have the strip defined to extract the forces and do the design. Transverse design can be done directly from the model instead of using separate Excel sheets for the same. Any questions? Sorry, sir? Yes, sir. I have an application for ISI as well. I'll come to that part. So I recently conducted a training for Central Railway as well on rail structure interaction, and we'll be having a training in IRISN as well very soon for RSI. The major strength is for the curved bridge. I'll mention that. It's in one of the slides that I'm yet to cover. For cable stayed and suspension bridges, firstly let me talk about the cable bridges. So for cable stayed and extra dose bridges, Sophistic has quite many advantages, as you can see over here. If I'm allowed to take names which have already been taken like STAD or MIDAS. If you go for MIDAS, STAD doesn't have it. So if you go for MIDAS, it has the cable force optimization. Sophistic also has cable force optimization, but something that Sophistic has more is the ballast load support lowering optimization. What is ballast load optimization? In case we are having the sequential construction, we come at a stage where we have to attach the key segment. The levels are not the same. What we do with MIDAS is we have to apply a load, analyze it, check the results, adjust the force, reanalyze it, check the force. If it's not on the same level, we again analyze. So it is an iterative approach with other programs, whereas in Sophistic, you just apply a point load, ask it to optimize, it gives you the factor to be applied to this force, which will bring it at the same level. So that is the ballast load optimization, supported within the optimization capabilities of Sophistic in the CSM module. Further, the major difference between Sophistic and any other bridge software which would handle cable state bridges is optimization considering catenary cables. So there is no software. Let's talk about MIDAS only because we have mentioned that during the introductory speech. So in MIDAS, if you go for the cable force optimization, you cannot optimize it using cable elements. If you just want to check, the unknown load factor feature, which is for the optimization of cable forces, deals with truss elements only. So you have to have truss elements modeled for the cables. Whereas in Sophistic, we can have catenary cables considered for the cable force optimization. The difference is, catenary being the nonlinear element having the sagging and large deformations, it gives us lesser forces. We have compared it for one of the single pylon cable state bridges, Mahalakshmi, that I mentioned, 172 and 78 meters in the back end. And there is about 18% material saving in cables, and that is significant cost. 18% material saving just because we are considering catenary cables instead of cable truss elements for the cable force optimization. So makes the design of such cable bridges economical, and that's the power of Sophistic. For pre-camber, of course, pre-camber is automatically applied in Sophistic. That's one of the strengths. But further, Sophistic is capable of considering the camber values for optimization of bridges as well. So whatever camber values we get as the post-processing, it can be considered for the optimization of the cable forces as well in Sophistic, unlike any other software in the industry. Now let's talk about suspension bridges. I know suspension bridges are pretty uncommon, but for suspension bridges as well, usually when we are dealing with suspension or network tied arch or arch wherever we have hangers, usually what we do is we install the hangers without any pretension. And what happens is hangers might be encountering 5-10 ton of force. The capacity is around 40 ton if I am not wrong. Usually 30 to 40 ton capacity hanger would be installed. So Sophistic has a feature which is optimization of hanger pretension. It is advantageous for hangers being used in network arch bridges or suspension bridges. Wherever we have hangers, Sophistic has the capability to optimize hanger forces as well. So we can calculate the hanger forces, save on the quantity of hangers, and that is how we save the cost and make the design economical. So whichever bridge type you are using hangers, you can save cost by using the hanger pretension optimization in Sophistic. Now this is not available in any of the programs, whether MIDAS or STAD you would be talking about. So MIDAS has only one feature, that is form finding. Apart from that, these are added benefits of Sophistic. When we are making the design economical, Sophistic makes it economical with hanger pretension optimization. And if you're dealing with curved suspension bridges, one major thing is you want the hangers to be parallel. So hangers should not be allowed to move longitudinally or in the transverse direction. This longitudinal movement is restrained by having the targets specified. This is called lengthening shortening optimization. So we have a lengthening shortening optimization which prevents the hangers from moving in the longitudinal direction and maintains the hangers parallel. So these are some value added features. If you're dealing with such bridges, you can certainly explore these features more and take advantage of it. Any questions so far? Now for substructure, of course, we have the substructure Excel automation that we have all seen. One major advantage is nonlinear P delta. What our code says for calculating these substructure forces is it gives the coefficients. We use the coefficient method to calculate the forces in substructure. I'm talking about the slender piles or piers. When we are using those coefficients, the forces are quite high. the code tells us that either we use those coefficients or we do the nonlinear analysis. And if we are doing the nonlinear analysis, the reference is Eurocode, which asks us to perform the buckling analysis, get the critical mode shape, do the geometric nonlinear analysis, and top of it do the material nonlinear analysis. If we talk about MIDAS, it cannot do material and geometric on the same model file. So that is where again it adds value that Sophistic meets that Eurocode's requirement of having the buckling mode shape saved and do the geometric and material nonlinear simultaneously on the same model to get the forces. And for this project, this is an actual project done by AECOM Mumbai, and this is of Maldives. And freestanding, I don't exactly remember the freestanding length now, but these are slender piles. And the resultant force was almost 1/20th of the forces calculated from the coefficient method. And that is how they justified their submission for the substructure forces. Any questions? Now, geotechnical 3D soil structure interaction, I'll just go through this quickly. Yes, Sophistic supports geotechnical analysis. We can have the diaphragm wall, staged excavation analysis, tunnel lining analysis and design. We can have slope stability using the strength reduction method. We can have soil structure interaction done. All three methods are there. Either we can have the soil spring simulated, which is the very common approach. So we can have the soil spring simulated in here for the soil structure interaction, or we can have the actual soil modeling. The advantage would be structure is modeled along with the finite element solid continuum model of soil, and we do the analysis and design from the same model. Alternatively, midway, we can have the half space utilized, where we give the borehole data, software interpolates to create the soil layers and does the soil structure interaction. So here, we are not giving the soil springs, we are not creating the soil, instead we are just giving the borehole data at multiple locations, software is creating the soil and doing the analysis of the building along with the soil. So that's the soil structure interaction capability of Sophistic in the same interface. Yes? This one? You can do it, you have it already. There is no separate module for solid modeling. There is no separate module. It is supported in the premium package itself. So you can do the solid modeling, there is no other requirement. Only thing is, if you require the nonlinear material models, like if you want the Moore-Coulomb, modified Moore-Coulomb material models, there is 2D geotechnical material model nonlinear module for the soil models. So if you need the nonlinear soil models, there is a module. But this is in HASE 3D, half space. Half space is a separate module. So I'm not sure Force is using it or not. Alright, now CFD is within the scope of software, and we take pride in telling you that Millau Viaduct, the tallest bridge in the world, is an application of Sophistic for CFD analysis. We can have 2D as well as 3D CFD analysis performed inside Sophistic, and for that we are integrated with Dolphin. Now let's talk about detailed finite element analysis. We can have detailed finite element analysis of joints in case we are required to do the stress checks. We can have crack propagation in concrete. We can have solid modeling, as well as we can have the full shell model. This is an actual application where full shell was done for the fatigue analysis of steel bridge. So we can have the fatigue analysis performed over here. We can have the stress checks done. So all these nonlinear analysis are within the scope of the software. Any questions? Any questions? Yes, sir. Sir, when we are modeling the soil, usually we calculate the assumption, okay, this is my size of the structure, so at least 2 times the depth, I should have the boundary located. So that way we decide the boundary, and at the boundary we have the roller springs for the vertical deformations, not allowing the translation but only the vertical deformations. We don't allow the horizontal because anyhow we are considering that it's 2 times the depth, so the effect will not go to the boundary. Unless your boundary is incorrect, we won't fall into the problem of lateral deformations, right? Yes, sir. But that as well, if you take 2 times the depth and 1.5 times the depth for the bottom boundary, the effects won't reach the boundary, sir, if I'm not wrong. Yes, so giving a roller on the side and a pin support at the bottom is sufficient in my understanding. So if there is anything else anyone would like to contribute, please feel free. Hmm. Yeah, it can have that effect, but we have to have boundary so far that that effect doesn't go to the boundary. Boundary does not have, in fact, it should be reversed. Boundary should not have an effect on the results of this model. All right. Yes. Yes, sir.
You compared results with respect to this tag. Only analysis, not design. Analysis.
Sir,
Sections are okay.
Sir, we have compared the results of composite bridges with STAD, with hand calculations, with MIDAS, with RM bridge. So I have calculations for all of these. So in case you're, I think the most common question is with hand calculation. So we have ways to match with hand calculation as well, because we know there are things in Sophistic that you can switch off to match hand calculations. We don't recommend that, but yes, that is a conservative approach which consultants opt for. So we can show that with this you can match the hand calculations as well.
We are not interested in the conservative or regulative.
Yeah.
The actual.
Actual would be the one that we would recommend, the efficient modeling, and that will give you lesser stresses. I would say if you are dealing with composite bridges, it will give you lesser stresses. So certainly you will have the economical results compared to what we are having with programs where, like you mentioned, STAD. So STAD has some limitations in terms of composite bridges, especially when you're dealing with pre-stress structures, there are quite many challenges. For pre-stress, in fact, people in the past have used MIDAS as well. Compared to MIDAS as well, Sophistic adds value in terms of pre-stress structures. So I think Pratik will be talking about creep distribution, right? So they have something that they have justified that makes the economical.
I'm not talking about the design. I'm talking about the analysis part.
Yeah, it's the part of analysis itself, sir. It's part of analysis itself.
Results, I want to results. What is the bending movement, what is shear force, you should calculate it with respect to the STAD model or MIDAS model.
Yes, sir.
Help compare.
Yes, sir. Yes,
You
sir.
worked in many softwares which you mentioned.
Yes, sir.
You wanted to have a discussion on that if you get some time.
Yes, sir. Yes, sir. We have the comparison. I can share it with you as well if you are interested. Yes. And yeah, that is where I was trying to add a further step that even after the comparison, we have ways that we can show how Sophistic is a bit more economical in terms of dealing with pre-stress structures. Yes, sir.
Asking questions. They are not able to
Can we use the mic for questions then?
not use the questions from the when they ask, only we can hear only your answer. I think it's the questions
It's switched off.
from them.
We can at least.
Here, that gives us what is the exact question, what you are answering. Or what you can do, you can just repeat the question before.
Okay. All right. I'll repeat the question before answering. I think that's a better suggestion. Thank you, sir. All right. Let's have a look at some of the landmark applications of Sophistic. So Atal Setu, the longest bridge, currently the longest bridge in India. It's an application of Sophistic software where Ramboll has full-fledgedly utilized Sophistic for the analysis and design. And we take pride that in telling you that it's purely an application of our software. Now moving on to railway bridges, Chenab Bridge is purely an application of Sophistic software where Leonard and partners have done the erection analysis of the arch using the suspended cables, constructed the arch, and then superstructure was designed by the other company, and they have done the blast loading analysis, rail structure interaction, and as well as the wind, dynamic wind analysis on this structure. So it's purely an application of Sophistic software. So basically wanted to highlight that amongst the landmark applications as well, we have in highways as well as in railways. Let's look at some more applications. Here is the third Bosphorus bridge, the unique hybrid bridge, combination of cable stayed and suspension, and application of Sophistic. Why Sophistic was the first choice for such application? Because it handles the nonlinearity of cable force optimization, parallelly the form finding of the main cable, and the optimization of hanger pretension. So three nonlinearities being run simultaneously and easily handled using Sophistic.
It's slow because this is a hybrid bridge between the suspension and the
Cable stayed.
cable stayed. I think a little bit slow. Our engineers should understand because what we know is the suspension as well as cable stayed. Whereas this bridge in Turkey, it is a combination of both, especially that. If it's slow, they are.
Okay, okay. Okay, sir, I'll try to go slow. I'll move on to the next. All right, sir, I'll do that. Sorry for that. As far as substructure is concerned, we can have open foundation, pile foundation, well foundation simulated in Sophistic. And this is a unique analysis where we are having the girder itself moving on the bridge, and then we can have contact spring. So Sophistic has a concept of contact spring. It's a moving spring, and we can simulate it between the crane and the bridge. We have the moving spring. While the crane is moving, along with the deformation of the bridge, the crane generates some forces. So that deformation of the bridge develops forces in the crane, and that can also be obtained if we use the moving springs at the location where this is in contact with the bridge. So this is the moving spring approach of Sophistic, and it's quite handy when we are trying to move the train on the rail itself. This is again an application. We have used it for panto-catenary interaction. We have when the locomotive is going, there is a pantograph connecting to the wires. There as well it has been used. There is a contact spring simulated in Sophistic connecting the panto to the wire electric line, and this panto is continuously moving. The vibration of the wire is studied, and there are limits that for the maximum time for which there can be loss between the panto and the wire is limited as per the Eurocode provisions, and that is being checked. So it is being used in Indian Railways as well. We have Infrasys techno consultants who are using Sophistic for the purpose of panto-catenary interaction study for the western line of railways in India. Sir.
Generally, when you have seen, Bangalore Metro phase 1, now they are all going for pre-tension U-girders. And earlier, if you look at the box girders, earlier when you had the box girders, the launching was done by this overhead gantry crane, right? So that the crane, that overhead gantry design was done totally separately, independently. Okay, and then they used to just give us the loads, the maximum reaction which would come at the legs. So we used to take those reactions and design our substructure and superstructure. But what he said is that we were not able to do is that when it is moving over the constructed span, the span will deflect, and because of that deflected span, you are having a secondary effect in the launcher. So that check is something a new thing. I mean, to be very frank, I mean, I had not heard that, or we had not done it even so far. So that's a very unique thing. Just wanted to highlight that. Thank you.
Thank you, sir. I'll move on to the next application. So this is about rail structure interaction. The major advantages of Sophistic with rail structure interaction is, of course, if you have used for RSI, when we talk about rail structure interaction, or also known as RSI, when we talk about RSI, we talk about softwares like Midas, where there are wizards to have the RSI done. So Sophistic also separately in Excel, we have developed the kind of wizard where basically the Excel automation for straight bridges. The major advantage in Sophistic comes when we are dealing with curved bridges. The limitation with Midas is it cannot have centrifugal forces calculated for the curvature, for the curved geometry. Sophistic has automatic capability to read the curvature and calculate centrifugal forces, and IRS asks us to get those centrifugal forces for the substructure design, and Sophistic does it automatically for you rather than doing manual calculation at each and every load position. Secondly, when we have to model the curved geometry, for curved bridges, the wizard doesn't work. So you have to manually model the geometry with any software that you're using. So while modeling the curved geometry, there are links which represent the ballast stiffness between the rail and the embankment or the bridge. These links are to be aligned tangential to the rail. And this alignment is hell lot of a job, at least takes a week for 300 meter span, because every link will have a different angle. At every sleeper position you have to align, measure the angle, align it. In Sophistic it's a matter of 30 seconds. Because we use AutoCAD, we just use the alignment option, sweep it along the curve, and everything is aligned. So alignment is automatically done. We have the actual bridge modeling, and we do the RSI considering the centrifugal forces as well for the curvature. So for curved, it's a significant advantage. We have Mr. G.S. Yadav. He is ex Irison. So he is also currently utilizing Sophistic for curved bridges. He has been using Midas as well in the past, so it's a mix for the software usage as far as his usage is concerned. But certainly this is the value addition which Sophistic has.
One question.
Sir. Office.
As far as the forces, the software, it's okay. When it comes to the thermal effects, especially in the curved bridge, especially in the composite, any work has been done? Because not much of the work has been done in the curved bridge, in the composite, and there are instances, there are majority of instances, there is breakage of the shear keys between the steel and the concrete, because it acts in a totally different way altogether as far as the girder is concerned and as far as the slab is concerned. You have considered that in whether this software takes into account, in addition to the forces, this thermal effect also in case?
Sir, only thing I can add is, only thing I can add to what you are saying is, for the thermal effects, it's simple. As per the code, we are applying the temperature load onto the section. Only thing what Sophistic adds is the warping and distortion being considered in the model. So there is no separate addition or separate consideration for that. Warping and distortion is automatically being considered. When we talk about curved, the distortion becomes a major concern, and that is already incorporated in the line model. So you don't need to go for separate shell model for that purpose.
For the benefit of our bridge engineers, especially the whom are doing these composite constructions where the steel girders are being used, whenever you go for the curved bridges, horizontal curved bridges, you must be extremely careful, because of we have rehabilitated, I think, about 2 to 3 bridges where they broke. And because of the loss of the shear between the deck slab and the steel girder below, the capacity of the whole of the span got reduced so much, and it got deflected also. It got deflected almost to the extent about 150 to 200 mm as a mid-span. And people, in fact, that was a very difficult proposition to identify what has gone wrong. Nothing gone wrong because of the shear keys, loss of shear keys. And of course, some rehabilitation measures are also there. I was just interested whether this software will take into account such things. I think it may not be. It may not be. It's okay.
All right. Now this is an application for the riding comfort. Except for NHSRCL, we did not happen to have this discussion at any other organization. So they are currently working with Japanese standards, and a Japanese software has been provided to them where they are trying to develop an Indian code as well, where we can see the riding comfort of the bogie. So basically, we model the bogie itself with the 3 springs connected to the rail, and we see the vibration of this bogie. That is possible with Sophistic, and there is another Japanese software which does the same. Any other program doesn't meet this requirement of riding comfort of the train itself. So for that purpose as well, Sophistic is quite a handy tool. Then we can have the boundary nonlinear dynamic analysis. We can have dampers, isolators simulated, and some more project applications we can have. These are some applications from our power users over the years. We have Spectrum, which have got variety of project applications with Sophistic. Like I mentioned, they have already been using it for over 15 years. And these are variety of applications. Apart from the analysis, you can see, apart from the global analysis and design, there is detailed analysis of the joint as well being done with Sophistic itself. Now Force, as they are our esteemed user for over a decade, they have variety of applications, and we can see not just in structures but also geotechnical applications and silos as well are being analyzed with Sophistic. Now here is another application from IABSE. The director of IABSE happens to be, any questions, sir? So director happens to be a an ex-employee from Rambol, so he got the exposure of Sophistic in Gammon, Rambol, and then he is using currently Sophistic extensively for a variety of projects. We can see for strutted box, for composite bridges, even for high-speed rail project where construction stage analysis is being done with Sophistic. Tech Tangent have variety of applications. So balance cantilever, cable stayed, extra dose bridges being done with Sophistic. And Vastuved, again, they have variety of applications with Sophistic. You can see a mix of steel composite bridges, box girder bridges, cable stayed bridges, even general structures, geotechnical applications as well that we saw. So overall, it's a mix of applications that we are having with Sophistic, and of course there are consultants who are exploring the Rhino Grasshopper capabilities as well with Sophistic, and again some more applications from StrutCon. SMC have got the geotechnical arch analysis and design done with Sophistic, as well as the superstructure design, and PSC portal frame as well done with Sophistic. Few more applications, and now so far. Any questions? Anyone? If we go through these presentation slides, it will be quite long. It's already 12:30. So what I'll do is let's move on to the workshop part. I'll skip these 4 parts for now. Later on, after, for how long are you presenting, if I may ask? 1 hour, right? So if we have time, I'll cover this part later on. Yeah, so I'll just move on to the.
Yeah, that way you can consider
Yeah.
towards whatever things are there that you can.
Yes, sir. The other parts I'll cover post the hands-on workshop, because for the bridges we have covered the part that we are going to require for the workshop. So this is what we are going to do. We are going to have the axis-based automation done. And this axis-based automation that we are going to do in the hands-on experience, we are going to have it for a single-span PSC composite bridge. So we are going to model a straight single-span PSC composite bridge using the axis and placements, and then we'll make changes in axis and placements to make this straight into a curved, skewed PSC composite bridge. So we'll see how we can do that using a single axis-based automated bridge project. So for this automation, we are going to define the axis placements, we are going to create the geometry, define boundary conditions, apply permanent loads, pre-stress. Then we'll export the model from CAD to Sophistic. We'll see the model, the straight bridge model, and then we'll change parameters and see how this model is parametric. So making these changes, we'll have the exposure to the parametric changes that Sophistic offers in the CAD interface, that is basically related to axis and placements. So without further ado, please, everyone, please go to this website, because we are going to use a tutorial from here. There are step-by-step PDF tutorials available on this website. We are going to refer to one of the tutorials. Of course, we are not going to follow the tutorial. Instead, that tutorial is GAD based. So in that tutorial, you can see an exercise where we are copying the GAD, creating the whole geometry, analyzing and designing a PSC composite bridge. But for today, we'll skip the part of GAD based modeling and replace it with axis based modeling. So this is what the exercise is for today. So please just open that tutorial from the website. This is the website where we are uploading all the tutorials customized for Indian standards. You'll find this tutorial on PSC composite bridge, and we'll open it. Yeah. I don't know. Mock drill is going on in Mumbai. I don't know about this. Please. Mock? Okay. Mock drill. Okay, so everyone has Sophistic Application Manager open on their system. I can't open it. Sir?
Civil sir.
Everyone, please open Sophistic Application Manager. It's there on your desktop. The reason is we are going to activate the license from there. So if you open Sophistic Application Manager, at the top you will see a yellow ribbon where it says activate license. Right? Please click on that. Please click on that activate license bar. Activate your license. For that you need to fill in the details. Once you fill in the details, you will get a code on your email ID. Please click on activate trial license. No sir, it's already installed. Can I see that? It should be installed. Sophistic application. Oh. Sophistic Application Manager should be installed on every system. At the top you should see the yellow strip. Please click on activate trial license. Fill in the details. You'll get a code on your email ID. You have to enter that code to activate the license for today on these systems. Sorry? No ma'am, not the license manager. Sophistic Application Manager. Yes. Please open it. Is it open already here? It's here. Activate trial license. On these systems it's not installed, sir. These licenses are just for the computers. For your personal usage, we will be sharing the license on your email itself along with the procedure on how to install the software. Is it done? You submitted? Can I see that, sir? Did you click on activate trial license?
It's here. You have to log in or sign in. They have changed the interface.
Okay.
Yes.
Yes, sir. You have to enter your email ID.
Enter your email ID.
The email ID that you are entering, you will get a code on that email ID. Once you submit the details.
members' email IDs valid, we can just share the licenses.
सर आपको ईमेल आया है ना? नहीं?
Otherwise, it takes time. Yes, yes. Unnecessary waste of time.
I can do that. May I present?
But then what we will do is we will have
I will read out.
Hello. See, everybody who had registered as of yesterday evening, okay, those email IDs we are having. So there he is going to send the link, the password for activating the thing. Okay, so you will be receiving those on your email IDs. You can take that and you can activate it. In the meanwhile, to save time, what we will do is we will ask Pratik to start his presentation. So he will finish his first part of his presentation and then we will break for lunch. And after lunch, he will have another half an hour of his presentation. And then after that, we will be having the whole afternoon session will be for our hands-on training. So that by the time the systems software will be activated in all the systems. Thank you. Okay, just I'll give you a very brief introduction of my friend Pratik here. He's my, I think how many, 10 years junior from IIT Bombay. Okay, so he was earlier working with Gammon and then he started his own firm called Force Structural Engineers with 4 of his colleagues. And he has worked on many prestigious projects and all. I mean, many of you might have seen the Hyderabad, what is that, Cheru, what's the name of the bridge? Durgam Cheru. Durgam Cheru bridge, the cable stayed one, that has been designed by his company. Okay.
I don't know, let me see.
Extra dose, yeah. Extra dose bridge. So that has been designed by his company.
Okay, I need the dongle for that. I think you need the dongle, right? Yeah,
So I'll just ask him to continue.
Yes,
Start.
yes. This should work.
In the meanwhile, all of you will be receiving the code on your email ID. So you can just check your email IDs and write the code in the, activate the license.
Okay.
Thank you.
Thank you so much, Arvind. I hope I'm audible. Is the mic? I don't think so. I know. So I'll have to hold this mic like this and then speak. So no worries. So good afternoon, everyone. Thank you, Arvind, for a generous introduction. And thank you, Shishir, for having such an elaborate presentation on Sophistic. I think my slides have gone redundant because of his content already. So I'll break this presentation into 2 parts. First, I'll give you a very brief introduction about ourselves, our company, what we have done so far. Will not take more than 5 to 10 minutes. And then post that, I'll speak about how we have used Sophistic in the past. We have a long history with Sophistic since the start. So I'll just quickly begin. I think it's not working. Can you help me with that? Yeah. We were established in year 2013, as Arvind mentioned. So I graduated from IIT Bombay with my dual degree in civil engineering and then master's in structural engineering in 2010. And then post that, we started working with Gammon India Limited, which is a very renowned firm in infrastructure. And we were very fortunate to work on some amazing bridge projects, and not just bridge projects, we also got opportunity to work on power projects where cooling towers and chimneys were designed at that time. So in 2013, we had this urge to start our own firm. So we, four of us came together and established our firm Force SE in 2013. So we all are, the four members are coming from IIT Bombay. And then we have got good graduates from very well-known institutes. We are trying to build a group of people who are sound civil engineers. I'll use it. We are based in Mumbai. Our only office is in Mumbai, Navi Mumbai. And right now we are a team of 85 people, which is a good mix of engineers, drafting and administration. We predominantly function only in the transportation infrastructure. And we do have a knack for special bridges or the long span bridges. I'll show you some of the works that we have done in the past. We have recently got ISO 9000 certified because we believe that organizations or big groups run through processes and systems. So it was important for us to align ourselves with good business practices. So we have got certified recently. And smaller or bigger, we have designed almost 400 plus bridges so far. These are some of our partners. We have worked with construction giants of the country, and we are also attempting to work with contractors outside India now. That's our aspirations, to grow ourselves now, go out of the country boundaries and work in different parts of the world. And now, because our workshop is related to a software analysis design, so we primarily work with Sophistic. It's our go-to software for all analysis purpose. We have a long history with them. So I'll briefly tell you that when we started in 2013, we were 3 years experience. So basically when we came out, we got a lot of caution from industry stalwarts that you're too young for starting up, and you don't have the gray hair to go and speak to somebody. Somebody will see and tell you that, oh, you're just a kid who has started. So but at that point of time, when we had nothing, so it's a partnership. It's not just an association or Sophistic is a vendor. But they offered us the license so that we could start, we could deliver some projects, and then when we got sustainable, we were able to pay them back. So we have a long history with them. And moving forward, definitely more other than Sophistic, we are working with Midas because now we are working on multiple projects. So there are needs where we have to use Midas models of others to do the checking. So more or less we are trying to work on Midas also, develop some capabilities there. For simpler assignments, we go with StatPro. And recently we have started using Idea Statica for steel connections, a brilliant software, which I think you all should look into. For alignment designs, we use AutoCAD Civil 3D. For our regular drawing generation, we are using AutoCAD LT. And for the future, we are trying to shift to the new BIM softwares, which are Revit, Tekla, Allplan, because we have a vision which I'll share you towards the end of our presentation, that how we can completely change the way we are building our bridges. So now coming to some of the projects, you can move forward. This is a 1 kilometer elevated viaduct in Mumbai to Nagpur Super Communication Expressway. This we have designed for AFCONs. You can move forward. In the same project, one of our signature project is, it's a viaduct, again, more than 1 kilometer long, with piers as tall as 55 meters and the standard span of 100 meters. Another complicated project in Mumbai-Vadodara Expressway, which we have done for L&T construction. I think you showed something like this where we had a very high skew angle. So we also had a similar problem where there was a 63-degree skew. So we had to go, and we had the constraint of using post-tension eye girders only. So we adopted the system where the deck slab is only cast on the portion where the carriageways is there, and rest of the girders are naked from the top. From the same project, 1 kilometer long ROB project, and this has got integral structure. So there is, over the piers, there is no bearing, and the structure is also resting on a single row of pile. Instead of a multi-row of pile, it is resting on a single row of pile. Coming to a different segment of river bridges. This is something which Shishi showed you. It's a 100-meter cantilever bridge. So how this works is that we have got two heavy abutments on the sides. The valley is around 80-meter deep, so it's practically unapproachable. So we had to build from the sides. So we started building. We had got these compartment, hollow concrete boxes. These are filled with local material so that we can add a lot of weight to the abutments. Now, once the abutments have a heavy weight, they're grounded. We start building from both the sides using cantilever form traveling. And we start building using 3-meter segments from both the side, applying post-tensioning. And when we reach to the middle, we had an option of connecting these two. But connecting these two would result in a problem of restriction in expansion and contraction of the bridge. So we had to solve this because we had to allow the movement of these two arms independently. So what we have done is inside this box girder, it's a single cell box girder. Inside this box girder, we have got a couple of steel beams which are hidden inside the box, which you can't see from here. They allow you to have a deflection continuity between the two arms. So when the one arm is trying to go down in the presence of live load, there is a girder running from this side to this side. So when this arm wants to go down, the steel girder inside pushes that force onto the other arm. So both the arms behave together. But then the steel girder is installed on bearings. So these arms can freely expand and contract. But at the same time, when there is a vertical load, they are behaving together. Yeah, so moving on to another type of a balance cantilever with a 50-meter side span and a couple of 100-meter main spans. This is in the northeastern region of India. One more bridge across Parwan River in Rajasthan. This is a typical 40-meter post-tensioned segmental box girder. Our recent achievement, I'll share a video with you, and this has been something of an engineering marvel for us. It has created history recently, and Sophistic has played a big role in this. I'll share you some of the construction engineering aspect of this bridge. A cable stayed bridge, this is located in Maharashtra. This is also a very unique problem. I have kept this picture here because I wanted to share the technicalities of this, is that we have got a constraint of making a 60-meter span because it's a bridge over a tributary of Ganga. So there is an expectation of a navigational channel of approximately 50 meters. So we had a span of 60 meters. But L&T gave us a constraint of using only post-tensioned eye girders because for rest of the project, they were using 35 meter to 40 meters eye girders, and they have the molds ready, they have the teams ready for that. So in order to make use of a 40-meter post-tensioned eye girder, what we did was we extended the pier cap portion. So what you see on the screen is the main pier, which is also a combination of two leaves. Over those leaf piers, we have installed 20-meter pre-tensioned eye girders. This one, what you see, is basically forming an extended pier cap. So this is 20 meters on top of the pier first. And over that 20-meter extended pier cap, we have launched the girders on it. So basically what you see is this part behaves simply supported over the 20-meter pier. So this is also precast, the main girders. The pier cap girders are also precast. Okay, this is a recent project that we have got. It's a render. So it's a prestigious project over creek near Bombay. And it has got a 120-meter span cable-stayed bridge for the navigation. Now just concluding few urban flyovers that we have done. So we have done the design of Zuari bridge approaches, not the cable-stayed part, but the approaches to Zuari, which is 28-meter wide deck. And this 28-meter wide deck is one of its kind. When we designed it in 2015, at that time, there were not many spine and wings in the country. I think the first one was JJ flyover in Mumbai, and probably this could be called as the second one. And this was 28 meters. Over this 10-meter spine, we have launched 9-meter cantilever wings on either side. So first, the spine is erected using the conventional launching girder. And approximate weight of the spine is nearly 50% of the total weight of the superstructure. So your launchers become very light. You launch the spine first, you apply the pre-stressing, the bridge becomes stable on its own weight. You use this spine segment to lift these two wings on either side, and then you apply a cross post tensioning from left to the right. So the entire 28-meter wide deck is post tensioned in transverse direction as well as in the longitudinal direction. One of our first few where we have played a role in architectural design also. This is in Tirupati, where we took inspiration from the local deity. So it basically takes inspiration from Garuda, which is the vehicle of Lord Venkateshwara. So the spine and wing shape, it looks like a spine and wing, but it is actually built in one go because the deck width was only 17 meters. So we could make the entire segment in one go. So the spine, which look here, and the two wings are basically cast monolithically. They are not cast separately, they are cast monolithically, and it is done through a launching girder approach. Another one in Nagpur, but this one is to showcase the strutted box. So this is again a 21-meter wide deck. So nowadays we are having a lot of wide decks. If you see the bridge projects that we are doing recently, we have also seen bridge deck widths of 36 meter, where we have got 8 lane elevated. So earlier I think we were making more of 12 meters and 14 meters. Nowadays I think 24, 25 meter is the new convention. So this is also a 21-meter 4-lane bridge. So the wide deck, we used a long cantilever, and the long cantilever was propped using these discrete struts. This is also a precast segmental construction and done through a launcher. Another bridge in Jabalpur, this is also a record in India, where we have done a 193-meter central span across the entire Madan Mahal station. So it's not just a railway line, it's basically the entire railway boundary of the Madan Mahal station, which has got around 4 lines of active railway moving. And we have built this 193-meter central span and 96-meter on the side spans. So this is also one of the longest extra doors bridge probably on a railway line. And last, we have done steel structures. Like this, just to showcase that we have done composite girders of in the range of 35 meter to 60 meters. So now moving on to the topic of this presentation, which we call it as a parametric modeling. So this has been the approach right from the beginning, because the word parameter, how I define it is that whenever you have a problem statement, that problem statement can be split into a function of certain parameters. Like if I very simply take a box culvert can be defined by its barrel length, its opening, and its thicknesses, and its skew probably when you have a skew. So these are the parameters which I'm referring to here. And move forward, Shesha. So almost many structures that we deal with in a day-to-day practice is like you deal with box culverts, minor bridges, I-girder bridges, single cell box girders. So all of these bridges actually have a very beautiful pattern which you can translate through mathematics into your analysis model. So your geometry is basically a function of all the depths and heights and widths. And then your loads are basically your country standards. So if you have wind loading, you have got certain formulations to apply wind loading, seismic loading, vehicle collision. All of these loads are also standardized. And most of them are also geometry dependent. Like if you have an exposure depth of the girder, so you can say that, okay, my wind load depends on the exposure depth. So the load can be applied as a function of the geometry. The parameters are basically decided by the designer. So when you're designing or analyzing, you know that your structure has these independent parameters which I can code. And rest everything is done by Sophistic, which we have done a lot of automation. I'll share some of them. Yes, we can move forward. So a little bit back. Yeah, so I want to emphasize on the importance of optimization nowadays, because it is becoming a very cutthroat market in infrastructure. Like we have been working with a lot of contractors, and what I see is that I am sure you must be seeing the results of infrastructure projects where the estimated cost is, if it is 100 rupees, then the lowest bidder is coming out to be somewhere in the range of 65 or 60, right? So I think there's a lot in play, and one place where designers are extremely important is the optimization, because when you deal with large infrastructure projects, 10-kilometer elevated, or maybe long cable stayed, multi-span extra dose bridges, one strand saved in one girder can result in crores of savings. So basically, it is very important that all of you as designers should definitely look into the aspect of optimization, because that's something what our contractors are looking for. And obviously, timely delivery is something which everybody wants their drawings yesterday, not even tomorrow. So like we have to make sure that we are always on our toes and we are delivering our drawings before time. So this parametric approach to analysis and design will help you to reach to both the goals of optimization as well as timely delivery. So as structural engineers, everything we do has a very beautiful mathematics underneath, and we just need to reveal it. So this is a way which we follow. I think Shishir has given you immense amount of information when it comes to Sophistic, because Sophistic is capable of handling a lot. When we started in year 2010, at that time, Sophistic was very popular in outside India, but it was not there in India. So we picked it up. And at that point of time, the new Rhino, grasshoppers, and a lot of input methods were not available at that time. So we picked up the most fundamental one, which is the text editor. And the best part about it is the programmability. So the moment you have this and you can write your functions, you can write your complete geometry, you can write your loads, whatever you think, you can basically write it in the form of these syntax. So Teddy is very powerful when it comes to writing these programs. So what we have done is we have created our own mini software within Sophistic. And these mini softwares, when I refer to, is basically simple Teddy files which tries to take the parameters of the structure and make the geometry, loading, construction stages, post-tensioning, load combination, etc. Everything can be coded. So for standard problems like eye girders, box culverts, maybe retaining walls, all of this, that they can be coded very conveniently. So for a standard problem, we believe that a text input is far more powerful. But obviously, not all structures are repeating, or they have a very consistent pattern. So definitely in that case, you have to go into a GUI or the AutoCAD input or Rhino input for that matter. So it's a bit unattractive. I think most of the young engineers find it a little difficult to start it, because when you start, it's just a blank sheet of paper. And you have to write syntax, which maybe doesn't make sense, right? This language in the beginning is not very intuitive. But I think with the modern tools of artificial intelligence like ChatGPT and other tools are available, and I think this has made it even more powerful, because now you can write these codes with the help of ChatGPT. So we have been doing it, and so whatever programs we have created so far, we have given it to ChatGPT, and ChatGPT has understood the code completely. And it has improved it. It has given us, so suppose if we are unable to make nice commentary to the code, so that if somebody wants to use it, they may get confused, okay, what does this mean? But if you give it to ChatGPT and ask it to do a commentary, it does a very good job. It basically helps you to write a detailed commentary of your own text file. So I think we did not have it in 2013, but I think the engineers right now have a very amazing tool. And this definitely becomes attractive along with your AI tools. It does have a little longer learning curve, but once you have the control on it, it's extremely powerful. I mean, I being a personal user for the last 15 years can strongly vouch for that. I personally prefer to write a text file than to use a GUI. So yes. So our style, we'll move on. So our style is that whenever we have a project, if it's a 10-kilometer long elevated corridor, so we know that what's the deck weight, what are the project specifications, you identify the seismic zones, wind speeds. So anything that is related to the project, you collect that information in the form of DBR, and then you set up your project with your cross sections, which you're going to use your design basis, your span arrangement. So if it's a 36-meter typical span or a 50-meter typical span, you basically identify at the start of the project. Once you have done that, so then you create your own design sheet, like how Shishir showed you that you can create that. So we do that, we set up for a particular project. So this Excel file helps us to create the parameters, and then those parameters, we pass it on to Sophistic to analyze. When we move from there, so once the analysis is run, we use their tabular result format to transfer the data to our Excel file again. And fortunately, this can also be now automated, if you move on. So earlier when we did it in 2010, this facility was not there. But now we have also connected all the tables back into Excel, so you don't have to go and copy and paste the results, which can result in errors. And the graphical outputs, like in your reports, we should definitely have bending moment diagrams, shear force diagrams, and stress patterns, top, like your top fiber, your bottom fiber. Everything should be there in your report because it makes it easy to check and understand. So we believe that we have to put a lot of images. So Sophistic also does a fabulous job here because we have got all the stress diagrams, bending moment diagrams stored in your PC, and then the Excel file calls all those images in particular format, and this Excel file itself becomes the report. So the next point is that once you have done this process multiple times of optimization, then you simply go and print your PDF. And this is the process that we follow. So whenever we have to create maybe 20 or 30 documents supporting your different span arrangement, different radius, maybe loading changes. So what we do is that once this thing is set up, then this process is repeated, and our Excel files are the reports. So we don't have to go to another software or another place to create a report. It's just that wherever you are doing the analysis and design, basically brings a clear, submittable report. So this was something which Shishir showed you, so I think I will not repeat it. This was again a system that created the substructure models automatically. One typical example, we did almost 100 spans of Ahmedabad Metro, and to give you an idea that when we did this, we first took a little bit of time to set the project, but then every superstructure was designed in less than an hour's time. So we did 19 meter to 37 meters. There was a variety of span lengths. And then radius was also continuously changing. There were some constant radius. There were some transition spans. There were some straight spans. So basically all of them, all the PNCs, if you do together, it was approximately 100 designs. So when we created this, then each superstructure took only 1 hour to create the complete design report. So that was something which was very powerful, and I think that comes from the power of the software as well, because we were able to program it. Moving forward, similarly, we have done other type of structures. So this was an earlier approach where we have to do the transverse analysis of a single cell box girder. So we use shell model. Again, so all of these parameters like your cantilever length, the depth at the cantilever, the length of the haunch, the width of the central portion, the depth of the box, all of this has been coded. And this automatically creates the shell model. And then loading is also, because we have 70R loading, class A loading, SV loading, we have coded it. So it starts from the left side and then moves in some intervals and goes to the right side. So with this virtue, we are able to automate the transverse analysis. Again, a very typical problem of composite eye girders. So here the number of girders can be varied, the skew can be changed, like post-tensioning can be changed. Yeah. So I think this has already been covered by Shishir, so I'll just quickly show you what we have done. So similar, when you are dealing with an abutment problem, so sometimes you have a very tall abutment, so you have to go for this smaller abutment. You can deal with a simple C-type abutment. So one single model does the design and analysis for both. What happened? Something went wrong. Yeah. I'll show you. Yeah. So I think I'll have just 5-6 slides after this. So, so another thing, again, a box culvert or a minor bridge, very simple structures, beautifully coded. A U-wall approach to the underpass, where you, in the approaches of an underpass, you have got these U-walls. So a U-wall can also be parameterized with respect to the height of the wall. And then the loads are applied depending on the height, and then thicknesses can be modeled. All of this can be varied and then designed multiple times. So this was done in 2012, which I have kept to just show you the, the intensity of the structure and what can be done. So this complete natural draft cooling tower is 165 meter tall, and it has got a diameter of 80 meters. And what you see is a complete shell model, which was generated through an Excel automation. The complicated wind loading, which is called as the ovaling load, was also applied through Excel. And this was done parametrically, so we were able to design multiple cooling towers by changing the heights and diameters. And in fact, the key takeaway from this was that we also designed the reinforcement from this. So, the softwares like STAD, they give you the capability to do analysis, but they don't offer you to design an RC section. But in this case, we utilize the capability of Sophistic to do the RC design. So basically, whatever you see, so I can say that maybe there are thousands of shell elements on this NDCT. Each and every element was designed by Sophistic, and then a reinforcement contour was given to us. And then based on that contours, we decided that how to detail it, where to put what reinforcement, vertical, radial. So the complete RC design of this cooling tower was done through Sophistic. There was no manual calculation in that. So right now we talked about the things that can be standardized, that can be parameterized, but obviously there are more structures which cannot be. So what you see on the screen are some of our creations which are unique. So like this is a cable stayed bridge in Mumbai, which we are doing right now. It's under construction phase. This is in Chennai. This is in Jabalpur. It has got some aesthetic pylons. This is the spine and wing model for Zuari, which I showed you. And this is the Isol network arch. So I'll quickly move to the next slide. Yeah. Okay. Yes. So as Shishir mentioned, that apart from the text input, you have got the CAD-based input, which is also very powerful. When you have got information in CAD, you can simply convert it into an analytical model. And the modern tech is now Grasshopper and Rhino, which there's a lot of buzz, and I think they have got very powerful software, but I think yes, it is yet to pick up, and the young engineers are now trying to do in Grasshopper and Rhino. And I think we spoke about SST before in your this. So I think one of the key features which I wanted to tell about Sophistic was that there is something called a Sophistic Structural Desktop, and there are multiple ways that you can input information in Sophistic. So as you saw, there is text editor, there is CAD-based input, and then there is another Rhino-based input. So SSD is something which is like a central platform which integrates them all together. So you can choose to do the geometry from the CAD, but then at the same time, if you decide to do loads differently, you can use a text-based input to use to input the loads. So this particular central engine, which basically allows you to use the most convenient input format, but at the end of the day, everything combines into one particular model, which has different input methods. So it's a very powerful feature of Sophistic. Yeah, so moving on, very powerful meshing. Seamless integration with various element types. So you're dealing with beam elements, shell elements, solid elements. Shell also you are dealing with plate elements, and then membrane forces elements. So all of this is very seamlessly integrated. You will never come across glitches in that. So we have been using it for a long time, so we know that. Axis-based definition, again very powerful, because you're dealing with when you're dealing with bridges, you don't get very much. This is one of the most important functionality where you can define the entire geometry, the post-tensioning tendons, and your loading. Everything can be defined just based on a local axis, which makes it very, very convenient. very good visualizations of the results. Some recent features like decreator, cut lines make it very easy to see the results for large plate elements. So I think one of the major problems that we faced a few years back was that when you're dealing with a large shell model and it gives you result, it basically throws so many results on you that it becomes difficult to find out it's like finding a needle in the haystack. So I think they have worked quite a deal on it, and they have created some very, very important features where you are able to work with a very large model and take out the data very conveniently. So I think it really helps here. Moving forward. Yes, so when you're dealing with different kinds of loads, so like, how you would know that a wind load is usually applied in all directions. So it's not just that you're applying wind only in the positive x direction. So when you apply loads in Sophistic, you can assign these properties also. So Sophistic intelligently understands that, okay, if it's a wind load, then it is likely to be applied in different directions. So if you're applying it in a plus x, it will automatically apply it to a minus x. So this is this is an important feature because it makes it very easy to write. You don't have to keep repeating the different kinds of loads. So the maxima happens, it makes sure that all loads which are acting together and have a negative effect on the structure simultaneously, it does a beautiful job to understand that. So if dead load is helping you, and if you tell that, okay, I don't want to have the helping effect of the dead load, you can simply tell Sophistic it in a very convenient way. It gives you a capability to do general section design. So if you have a oval shape or a hexagonal, or for that, simple rectangular sections become difficult because we can't do it in Excel. So gives you a very good tool to do any kind of section, and not just with reinforcement, but also with pre-stressing as your reinforcement. Quite advanced analysis capabilities, which I think he's already covered. All kinds of non-linearities, whether it is geometric or materials. When you have concrete cracked, so your stiffness changes. But in all of our model, what we do is we model the complete section. So the stiffness remains the same. But in reality, when the structure behaves, when it experiences cracking, the stiffness changes. So when you have to go into an advanced analysis capabilities, it has geometric as well as material nonlinearity. It has got cable sags, which you mentioned that you can work on catenary profiles, and cable force optimizations. Buckling analysis, which we have recently implemented to significantly optimize the network arch, which I'll be showing you right away. And we can move forward. Yes. And I feel that one of the best softwares to handle construction stage analysis, and I'm going to show you a video next to this, where Sophistic was utilized for the complete engineering. Do we have a sound here? No. It's okay. It's okay. No worries. Yeah, I wanted to share with all of them. So this is a day before when the arch is ready to be launched, and it was constructed behind the abutment. It was 100-meter span, and the weight is 450 tons for the entire structure without the deck slab. This is a Sophistic model for the permanent design. This was the launch day when it was done through a control room. The control room is not very fancy. As you can see on the screen, it's the arch is basically launched on a system of ropes and towers. This is the main rope on which there is a cable crane, and over the cable crane, the arch front side is hanging. So approximately 225 tons of load was transmitted over this cable crane onto the cables. The 30-meter tower on the movement side and 10-meter tower on the other side. This was captured when it was in the middle, and it took us 6 hours to launch it from the abutment A1 to abutment A2. So as you can see, this is probably the world record for transferring a bridge over ropes. I mean, we were trying to find the maximum load that has been transferred on to suspension cables like this. So this is, China has done around 215 tons. And this is 225 tons that we have launched. So the complete engineering, including the permanent design, the construction methodology, all the elements of it, the towers, the cable crane, the winches, everything was designed. And with the help of Sophistic, we did the complete construction stage analysis. And this was done around a month back. Yeah, so another one which we are doing right now is like something closer to a Chenab bridge, where we have got thrust arches. So the arches are supported on the rock at the bottom, and then we are building it with the help of temporary stay cables over these towers. The cables are deflected over the towers, and then there's a backstay. The arch is built, the key segments is applied, and then we remove these cables because the arch is now stable once it is complete. So this is the construction stage of the arch, and then once we have erected the arch, then we feed the deck elements, and first we do it on the vertical suspension. So what you can see is all the hangers are vertical, but we wanted to utilize the structural benefit of a network arch, which you just saw that there are crisscross hangers. So the crisscross hangers help you with the bending of the deck and the tie. So we wanted to do that. So now the crisscross hangers are applied. And then once the crisscross hangers are in place, then all the temporary vertical hangers are removed and the bridge reaches to its final state. So all of this, I'm showing this because I wanted to show you the advanced capital.
Hello,
Yeah.
Pratik, just one query.
Yes.
What is the advantage of having crisscross as compared to the vertical hangers? Can you just explain?
Sure. I'll use the marker to do that. Yes, so I'll first draw an arch. So like how an arch truly functions is that when you have a load coming onto the deck level, so I will talk about the vertical hangers first. So when you have a load coming here, first it is, so the vehicle tire is coming on the deck. The deck slab transfers it to the transverse beam. The transverse beam carries the load to the tie. Now the tie wants to deflect down. When the tie wants to deflect downwards, these hangers are pulled. When these hangers are pulled, the arch is also pulled downwards. Now, when the arch is being pulled downwards, there's a natural tendency of the arch to straighten up. So when it is trying to come here, it will be this, and that's why there will be an elongation on this side. So this is the phenomena through which a standard arch functions, whether it is a vertical hanger or it's a crisscross hanger. Now, the thing is, when you have a point load, something like this, so these point loads are mostly transmitted to these points, and there is a local bending of the arch which is experienced. So this bending of the arch makes, and so finally when we design this arch section, the arch section is designed for two components, which is the axial force, which is also a predominant force because most of the load is being carried by compression in the arch and the tension in the tie. So there is a significant axial force, but there is also a very significant bending moment that can determine the section here. So the idea of going into a network arch is that when you have crisscross hangers, so what they do is when then there's a point load, what we try to do is we try to make hangers like this, and there is another set of parallel hangers will go in this direction. So what we are trying to do is when we apply this load, we don't go from here to here, but rather we go from this way to this way. So in this way, what is happening is that we are trying to convert the vertical load into a radial force. Like how if you remember that if an arch experiences a radial force, it is likely to have very less bending moment because all the forces are pointed towards the center. So this is basically when you have this kind of a force configuration which is pointing towards the center, it predominantly goes into compression and the tension. There is very less bending, but when it comes vertical, so when the forces are vertical, they are not radial. So because when they are not radial, they are likely to cause a significant bending moment in the arch. So the idea is that when you go for crisscross hangers, it makes sure that whatever load you are implementing onto the bridge deck gets converted into significantly into radial forces, like here as well as here. So the net force is carried by the components of these, but this will make sure that the arch always has a radial force, resulting in very less bending moment. So this particular part goes significantly down in case of a network arch. And this is no problem because axial forces, you require a very small section to transmit. If you have done a very basic calculation, you can simply see that even a small section, when experiencing an axial load, can be designed in a very small section. But the moment bending comes, bending results into a much larger dimensions for any cross section. So the idea is to reduce this part so that we design predominantly for the axial force. So this results into much slender section. So even this one, it's a 180-meter arch. And what you see, the proportion of the arches, if you see, these are the real proportions to the scale. So the size of the arch, if you see, is quite slender as compared to, you might have seen the RDSO bowstring. So they use a vertical hanger system. And there the bending is to increase the size of these members just to make sure that the local bendings can be taken care of. So at the end of the stages, everybody wants to quote low. So as Shishir showed you the method that through your Excel files you can do multiple runs and you can reach to an optimized solution. While you're doing a detailed engineering, the optimization results in quantity savings. So at the end of the day, you bring some savings to the contractor and you become their trusted partners. As I mentioned, AI can be leveraged to create these models because the AI has become very powerful nowadays, and I think we should all use it on a day-to-day basis. And going away from the analytical or sophistic part, I think what I wanted to share with all of you is the future of drawings. Is that parametric model has been used in analysis for sure, but we should be using parametric approach to drawings also. So like the modern Revit or BIM platforms, so the idea is to create 3D models. So we should completely go away from building 2D drawings. I think all of us right now are using AutoCAD, light version and our draftsmen are creating lines and doing the annotations and making mistakes in one section and changing here but not changing there, and that basically reduces the quality of drawings. So I think the future lies in that we start creating 3D models and completely get rid of 2D drawings altogether, because in future I feel that the sites will also be equipped to read these 3D models. And I think it's more intuitive also to use a 3D model to understand something. Like, I feel that it's a little counterproductive to first imagine a structure in 3D, convert it into a 2D drawing, send the 2D drawing to a construction site, ask the engineer to read those 2D drawings, and then again imagine in his head like a 3D model. So basically, it's a little counterproductive for, but since the technology did not exist, so I think that was the only way. But I think nowadays we do have the capabilities, and I think we are trying to build in that direction, that we are making 3D models. Like this is one of our recent attempts, that one of a bridge we are trying to create completely in Grasshopper. So this is the visual programming. It looks very scary, but it's pretty simple. So what we have done is we have coded the complete superstructure by the means of these parameters here. And these Grasshopper creates the 3D geometry in Rhino. And this Rhino geometry is being pulled to Tekla. So Tekla is a software which basically handles the, the 3D model creation. Rhino is just an interface because this has got very powerful NURB theory to create 3D surfaces. So this particular combination gives you very complicated surfaces very easily. And then once you have the geometries in Rhino, you can simply move to Tekla for your further usage. So right now, what we are trying to do is that we feel that it's not completely possible to shift to a 3D model approach because our sites are not equipped, our authority engineers are not equipped to approve a 3D model, because right now what we are doing is stamping and signing on papers. But I think future is going to be like that. So right now what we are trying to do is make a 3D model. But once we have the 3D model, then use cut sections. Like, you can make cuts at various locations. You can see elevations, you can see plan, and then you ask the software to make drawings for you, because what it can do is it can identify what are the elements there in a cross section, and it can mark the lines for you. So the drawings are also now created through this. Now the advantage of this is that suppose during the course of execution we realize that, oh no, we need to increase the size of this haunch. So we go and do it in a 3D model. The 3D model gets updated here, and all the drawings which are linked to that particular superstructure and has the element of that haunch will automatically change, the dimensions will change, and the same model gets reflected onto the site. So basically nobody is using an outdated version of any information. So all the information is up to date. So that's the idea. We are quite far ahead in this direction. So this is another model from Tirupati, and this is the reinforcement drawing from that. So even the reinforcement can be done parametrically, and it is very helpful that you can take out the quantity takeoffs also. So once you have modeled it, once you have modeled one bar, you can simply translate it. All of these bars can be visually seen. You can do a clash detection for it. So you know that, okay, whenever there is a congestion, you can clearly see that whether the site will be able to make it or not. If there is an issue, then you can simply look into it, you can change the detailing, and once this is done, your rebar consumption can be done easily from this. And not just this, I think the applications go far beyond this. Nowadays, people are also trying to use these models for planning. So once you have the model for the entire project, what the construction site can do is basically use that model to monitor their progress also. So if suppose concreting is done, they can mark it in the model that this part of the concrete is done. So the software automatically can calculate the progress. It can record the dates. It can help you with billing. It can help you with future surveillance and whatnot. I mean, you just think of it, and I think these 3D models are becoming a boon. So I think the idea was to share this with you to bring that motivation that when now, because many of you are young engineers, and I think I want you guys to take this up. And I also request the senior people who are into the authorities to gracefully accept the new technology and try to implement this with maybe some smaller assignments first, like maybe a 30-meter bridge. You can take it up, you can start doing it in this fashion. If everything goes well, we can start, maybe doing kilometers of elevated corridors through this. So, yes. Finally, a vote of thanks to all of you for patiently listening. I think, I hope I did not bore you guys. And to ING, IABSE and BIT for giving me this opportunity to speak in front of you. And to Sophistic, as always, for 15 years of association. And this is force written in Sophistic.
Yeah. Now.
Thank you so much.
Now. Here.
Yes, sir. Yes, sir.
We are supposed to ask questions.
Yes. I want to encourage people, because I always say when so I have a training course in my organization where I encourage people to ask questions. How stupid it is, it doesn't matter. You should ask questions. If it comes to you, you should ask it.
Yeah, starts from me. Others will also ask a few questions.
Yes, sir.
You just open your PPT.
Yes, sir. So can you mention the slide?
You go back to spine and wing bridges.
Which one? Spine and wing?
Spine and wing.
The one which I showed you, Zuari Bridge?
Yeah. No, you're still back.
I think, I think it went too far. Yeah, you can open and yeah.
See, in
this one. Slightly up.
Spine and wing.
Yes, sir.
I think what happens is the aspect ratio of the cross section plays a major role. I don't know how you people do it, because aspect ratio means the weight of or stiffness of the spine with respect to the both cantilevers. That plays a major role, and normally it is not taken care. And one more thing is, you said about Nagpur, that strut and
Strutted box.
bracket.
Yeah. Next to
That bracket, I think in the strut and bracket type, you designers are, yeah, exactly. You designers are giving more steeper struts. It should be more verticality should be more increased, so that you will have a better load transfer. Here what happens, the bending comes into picture, and if some overload is there from the top, there are chances of breakage of your struts, and it happened also.
So I think, so when you're building maybe thousands of struts, one is likely to get broken. I agree with you on that. And I totally agree with you that the inclination of the strut should increase. Because there is a very simple, plain logic to it that whenever you have a load here, this strut provides you the compression, and then this particular triangle which is being formed takes the tension. And so there's a very simple, household bracket what we see. Like when we want to put a small thing on the wall, what we do is we simply go for this triangular bracket and put something on it. So it's basically that only, that these struts. So if the angle of the strut gets shallow, then it's a very simple plain logic that if you have a force here, and if this angle gets shallower, the compression is likely to increase, and likely to increase by exponential, because the trigonometry works in an exponential function. So that's why you should have angles which are practical, and if the compression increase, then definitely the tension will also increase. So resulting higher tensions will make the structure go into extreme cracking, and that's why you might have to go for cross pre-stressing. So I agree with sir that the angles should be as comfortable as it can be, but yes, it does increase the depth of the box. So you have a trade-off. You can't simply go with a 5-meter box just because you want to have a good strut angle, but at the same time you don't want to go a 2-meter box because of the very poor strut angle. So as a designer, we always are in a position that we have to do this trade-off. So we try to do the best we can, sir.
And now I think food is waiting.
Yes, sir.
And we can food.
Sure. Everybody must be hungry.
All of you would have received the code for activating the software in your email IDs. Those who have not received it, please contact Saheli here. She will help you in getting that. But all those who had registered or who had written their email IDs very legibly, they have definitely received it. Okay, so you can just log in onto the system and activate that. And post lunch, we can carry on with the hands-on training. And I would like to thank Pratik for the wonderful presentation. The thing is that we are just always thinking in one line, that we are, as a civil engineer, we have to do this one only. But the way in which the technology is evolving now with more and more automation, AI and all coming in, and all of us, those who are practicing engineers, they will be knowing that everybody is under pressure to deliver the designs and drawings in a very, very short time. So here, this automation, or if you adopt it, not just in Sophistic, even, it is available in, say, STAD or Midas and all. Lot of things are there available. You can check on their websites or on YouTube and all. So I would request all of you to, upgrade yourself, upgrade your knowledge and all, so that this will be helpful. And thank you, Pratik, for the wonderful presentation. Sir, I would request Jay Prasad sir to give him a bouquet, sir, please. Yeah, afternoon, let him give. We'll give one more bouquet. One more. Yeah, lunch is ready on the corner in the same floor, just near the Ramegowda seminar hall. Just near there, it is available. So we'll have a break of 30 minutes for lunch, and then we will join again. Thank you.
Hope everybody occupied their respective seats. Some are yet to come. We will commence the second session post-lunch. As of now, the feedback, what I got, it is very good. And attendees also, they have understood majority of the things what has been told by the told on the dais. However, we expect the organizers, we expect you to ask questions which is lacking. Especially the government departments, kindly ask questions. Don't bother. Nobody will think about you whether you know the work or not. But some questions will keep the organizers comfortable. We will commence the post session. I think Mr. Jain Saab, you can start the job.
Okay. Thank you, sir. You want to change the batteries? Okay. I think, yeah, please. I'll use this. I'll draw then.
Shishir, just if you can explain what email has been sent and how they can load that, they can do it in the while he's explaining.
I hope everyone has got the license activated for Sophistic. In case you haven't, you have been sent an email on which there is a license file. So if your email ID was correctly mentioned over there, we have shared an email in which license file is there. You just need to download it and double click on it to activate the license in case your trial license isn't activated till now. So just make sure your license is activated so that we can get started once this technical discussion will be over. And if you're facing any problem, just raise your hand. We'll be there to assist you.
Okay, so I'll be taking another 20 minutes of yours, and just because Shishir showed one of the examples where the launcher was moving, and you could see that there is a concept of a moving spring. So from that I got an idea that I thought I'll share it with you, because a lot of bridge engineers tend to miss this phenomena, and this could be an interesting fact to know. So like how we see that, like in Bangalore Metro, I'm sure we must have built a lot of box girders in our existing alignments, right? So the phenomena with the box girders so first I'll briefly speak about the launching method. So you have the launching girder on the board right now. You can see it in the green. The first leg is resting on the already erected span. So this span is already erected, and we are in the process of building a new span through this launching girder. So the leg is resting on the erected span, and the weight is getting transferred to the bearings, and this is the first support. And on the other side, the pier, which is yet to receive the superstructure, there is a leg on it. So the launching girder is supported on these two locations. Now how we build it is that at the grade level, we bring our trailer, and on the trailer, we bring our segment. This segment is brought onto the ground, and then with the help of high strength bars or tension bars, we lift these segments, and then we hold these segments onto the launching girder. So this process is repeated multiple times, and all the segments of this particular span hanging on this particular launching girder. So this is a stage which we need to visualize right now. So what has happened is the entire weight of the superstructure is currently on the launching girder. I think clear so far that I have lifted all the segments. So the weight of the superstructure, let's say it was supposed to be say 1,000 tons. So it's already there hanging on the launching girder. In this process, what we certainly know is that the launching girder must have deformed like this because it is experiencing a 1,000-ton load. So between its supports, it is likely to have deflected. So let's say we call this deflection as delta launching girder LG. Now what we do is, after this, we align these segments together. We dry match them so that all the puzzles, all the pieces of the puzzles align together. We apply the epoxy grout to these sections, and then we basically join them all together and apply a temporary pre-stressing. Till the time this particular, now I'll basically draw the finished product. Okay. So this would be the current status of the bridge, that all the segments are matched together, epoxy is applied, and segments are joined together with the help of temporary PT. There is a PT inside which basically brings all those segments together, and the glue inside oozes out to make sure that this joint is perfectly sealed. Now, from the load point of view, the entire weight of the superstructure is still on the launching girder. So the launching girder is under a deflected state. Now comes the starting of the pre-stressing. So when we do the pre-stressing, so we will start applying the cables to it. Now the moment we apply cables to the segmental box section, the weight of the superstructure, so basically there will be a support here because finally at the end of the day we will have to lower it on the bearing. So I've exaggerated because I want to do not draw it again. So here it is almost close to the support. Now when we start applying the pre-stress, the tendency of the box girder, the weight of the box girder eventually start converting into the shear force in the webs. So as I apply the first cable, the partial weight of the superstructure gets transferred as the shear force in the web into the bearings. Because eventually the final stage is that all the pre-stressing is applied, the superstructure is able to carry its own weight, and finally it is resting on the bearing locations. Now in this case, this process is happening gradually. It doesn't happen immediately that all the cables are applied and the force is transferred. So in this gradual process, when we apply the first cable, some fraction of the weight goes as shear force to the bearings. Another cable is applied. Now as you keep applying those cables, the weight gets transferred from these launching hangers and start going from webs to the bearing through shear force. Now what we need to understand is that this particular pre-stressing is, when it is applied, it is causing a hog. Everybody is familiar with this phenomena that when we apply the pre-stress, it is likely to hog by a certain amount. So let's say the bridge hogs up by delta span. Now the delta span is usually of a much smaller value because the concrete has a huge amount of stiffness here. And the launching girder, being a steel member, is likely to be more flexible than a concrete section. So what we need to principally assume is that this is likely to be more flexible and this to be less flexible. So that means that for the same load which is acting in the vertical direction, this is expected to be higher and this is expected to be lower. I am talking on a very qualitative level. These numbers can be evaluated. So now what is happening is that now this hogging has happened. So the span has deflected by delta span, and the delta LG would have been released by this magnitude, which is delta LG minus delta span. But since we know that delta LG is a much larger value as compared to the delta span, that means that the full deformation of the launching girder is not yet released. all clear? If there is any question, stop me in between. So the launching girder is yet under a deformed shape, and at the same time, the pre-stressing is being applied, and the pre-stressing is making the force, making the load move from shear force to the bearing. Because the LG has not fully recovered to its original position, it is likely that these hangers will start exerting upward force. I'll try to exaggerate a little bit. This is the span hogging. This is the LG sag. So these hangers, now just let us look at the extreme situation that complete load is being transferred from the web, which is likely to happen eventually. So the complete force is happening through web. So that means that the launcher will try to recover its force. It will try to come back to its original position because the span doesn't want to apply a load on the LG, right? Because the span wants to transfer the forces from the web. But the LG is currently under a heavy deformation. So what it will try to do is it will try to come back to its neutral position, which is the flat one, under its own self-weight. So this particular deformation which is left in the girder, in the launching girder, will try to pull up these hangers up. So now you can imagine that we have applied pre-stressing. Now pre-stressing, what it was supposed to do is supposed to give a hogging moment so that the section is safe. So there is likely tension, very small tension, small compression on the top, and a very heavy compression at the bottom. Everybody agrees because it's the stage when there is only dead load and only pre-stressing. There is no external load, no SIDL, no wearing code, no live load. No losses also for pre-stressing. So this is a critical case when you have the full pre-stressing applied, you have a very small compression on the top, you have a very large compression at the bottom. Now imagine this particular force. So right now, it has been seen that a lot of people ignore, they just kind of miss out this force. But it's a pretty significant force which is also acting in the direction of the pre-stress. So maybe in your analysis, when you do it either by Sophistic or any other software, you will probably not model this. You will only model the span. You will say, okay, applying this pre-stressing, I get, say, 20 MPa at the bottom, 1 MPa at the top. This is sufficient. My design is okay. But during the construction stage, this particular force, which is secret, which is not known to you, is also exerting an upward direction force. Now, this upward direction force will increase the hog. Increasing the hog means this 20 MPa is likely to go to maybe 25 or 27 or 28, depending on the deflection of the LG. And this particular, where we had very less compression, maybe 1 MPa or 2 MPa, is likely to go under tension. Segmental structures are very bad when it comes to tension, because the moment you have even a bit of tension here, the joints will start to open. Opening of the joint will result in the reduction of the inertia of the box. So if I have a box something like this, if I open it from the top, the deck is no more. So you suddenly lose a lot of inertia. So that's why tensions are very dangerous for segmental bridges. So right now, if we are not understanding this phenomena, and if we are letting the launching girder do whatever it is doing without looking at these suspender forces, it is likely that you are experiencing far more stresses than in your design. So this is an unsafe condition which is likely to build in the structure if we do not pay attention. So this is something which we realize that this is a problematic situation and we need to consider this. So the way to mitigate this is that we start building the prestress. So let's say if we have got 18 cables, and when we do the analysis, we certainly know that, okay, 10 cables may be good enough for dead load. Another 8 cables are for the future loading, say live loading, SIDL, losses, everything. So in that case, the designer should recommend that you should stress 10 cables first. Now, the moment you stress 10 cables, it is likely that the span has just started transferring the full forces to the end. So this 20 MPa is not yet built because 8 cables are yet remaining. So you are not here. You are somewhere in the range of maybe 10 MPa. So at that stage, you should ask the contractor to immediately position this and release these suspenders. Because the moment you release these suspenders, that means that the launcher can conveniently go up without exerting any force. So the launcher will recover to its position. It will release the load of the bridge. The bridge load will eventually transfer from the webs to the bearings. And now you are safe, because now when you do apply the next 8 cables, your launcher is not doing anything to you. So this is something which I wanted to share with all of you, because I think this is a kind of unheard phenomena at times. But because we are building so many box girder bridges, it is extremely important that we have this stage stressing clearly mentioned in the drawings, to which this must be called as stage 1 before the release of suspenders. And once the suspenders are released, then this is stage 2, which is the residual cables that you should be stressing. So this is something which I wanted to share as a fun fact for you. And I think, sir, I should give the stage to Shishir. Shishir, you may start your workshop now. Yes, sir. If sir. Yes, sir. So basically, the situation was something like that. The hog was approximately of the order of 25 mm, but the deflection of this was around 80 mm. So that's quite significant. That's why I mentioned this, because it would have been very less. It's okay. I mean, you have construction tolerances, design tolerances, so this would have been managed. But because the gap is significantly large, it is definitely a good practice to specify a break. And this will make sure that so because you have seen the spine and wing failures, right? Yes, the spine and wing failures are basically a resultant of a mix of those things. That you have failures at the quarter span, 1/4 of the span, always. All of the spine and wings fail at quarter span, because the cables go down like this and then become flat. So this is the point where you have the maximum pre-stress moment. So your P into E, which is the pre-stressing moment, that's maximum at the quarter span because of the eccentricity of the cables. But your dead load grows like a parabola. So that does not have the maximum moment at the quarter span. So that means that pre-stressing is extremely powerful at the quarter span, and the dead load is not able to counter that enough. In the mid-span, that's not a problem, because P into E is being cancelled by the dead load. So this is the point where the maximum stresses are likely to build. Now as a designer, I know that it goes up to 24 MPa, because I have designed Zuari, I know it goes up to 24. But in reality, if you don't do the epoxy properly, if you don't take the effect of the launcher, all of this basically builds up to maybe 30 MPa or 32 MPa. This one, sir? Yes. So, correct. So, basically in that case, what we are trying to say is we are trying to match these deformations. But the moment you try to match these deformations, your cost of the launching girder will go up. And today, again, the launcher manufacturers are also competing for their launchers, so they are trying to reduce the structural steel weight. Yeah. So compatibility would be always be welcome, but difficult. Yes. So I think the best way designer can resolve this is simply by breaking this. It's absolutely simple. There is no issue. The contractor can keep on stressing, then release, and then keep on stressing. There is no change of manpower or jack relocation. Nothing is there. It's just a very simple process through which you can secure the structure under this condition. 2 stage, sir. Even for a regular box girder, single cell, double cell, it's recommended. Spine and wings are extreme cases because they are likely to go under extreme stresses, because the wing weight has not yet come. Wing weight is an helping agent. Wing weight is not there. So they are likely to experience more compression. Yes. Second stage is done on the temporary bearing. Which one, sir? Second stage? Yeah. Once you transfer the forces through shear to bearing, that means this is free. This you can take forward also, because the structure is stable under its own dead load with 10 cables. So there is absolutely no problem. Yes. So I think maybe in your box girders, this could be mandated that this has to be followed. And so this is it. So any other question I would like to take? Else I will hand it over to Shishir then.
Yeah, I would just like to add to this. See, you would have seen spine and wing construction, a lot of it being done. The latest one what we have nearby is our Mysore Road flyover, just near Biddi, after Kengeri, right? So first what they do, they put the spine. The weight of the spine, if you look at the overall bending moment, it comes to around 33%, right? Okay, and if you see the eye, stiffness of that comes to again around 35 to 40% of the overall complete section. So on a section which is just 40% stiff, you are applying, and which self weight is just around 33%, you are applying the full pre-stressing force which is supposed to take care of spine plus wing plus your SIDL plus live load, everything combined. So that results in very, very, very huge compression at the bottom. And what he said this, because as per our code, you can go up to 0.48 FCK. So if it is M50, you are almost at 24, 25. And then this thing happens, you are going at 30, 35. And that is why about, I think, 2 years back or something, almost 6, 7 failures were noticed in this spine and rib type of construction all over the country. Bihar, Himachal, Delhi, I think 2, 3 happened there. And at that time, NHA had put a ban on the construction of spine and rib construction until the reason for this was found out and all. So there was a committee headed by Mahesh Tandon sir and all who did the thing. So during that period, I interacted a lot with Pratik, and we put forth a few guidelines which during our B4 committee meeting, we had these things had come up. So just wanted to add to that. Thank you.
It's saddening to see that ban, because it's a beautiful structure. If done properly, it's a very nice structure for wide decks. But there was a sudden ban on the structure. So it was, this is how we function. Whenever something like this happens, we take the most conservative actions. But I think now it's all open. And I have also written an article on how to... Yes, sir. Okay.
When almost all our designs were finalized, then we got a letter from NHA.
Change it.
Go with regular form.
That's...
It is actually a very interesting spine and wing. It can be of very combinations. Like our Arvind Salech and myself, we went to Banglore. RCC spine.
Okay.
4 box.
Okay.
RCC.
Okay.
Simple civil supported.
Mm-hmm.
And the wings are pre-stressed.
Cross PT. Okay.
It was PT was building PT.
Okay. Flat slab. Yeah.
Flat.
Yeah. Transverse PT.
Easy to construct.
Mm-hmm.
I think somebody from Yellow.
Within near Vellore. Ambur.
So simple construction.
Yeah. That's true.
Something went wrong, and of course they resolved the issue there.
Hmm.
And that was Nagpur's, as you suggested, neither it can be made full flat, nor
Yeah.
it should be balanced.
Balanced. Yeah.
But the balance they are not doing.
Yes, I saw, because of the curvature, actually the wing angle also goes down. So if you have a flat bottom, you can have a better angle. Yes, sir. So anyways, any other question, or else I'll hand it over to Shishir then.
Question at least one from this side, one from this side, one on this side. Any question, no problem.
Yes, sir. Double-decker bridges. So what's the particular question? How to build?
He's asking whether the software can handle double-decker bridges.
Yes, certainly. I mean, in fact, double-decker bridges do require special attention when it comes to seismic design, because it's no more a single degree of freedom system. It becomes a 2 degree of freedom system. So you can't simply go with ASM. Yes. It's a steel truss, yeah.
Especially the software and construction, oriented towards that. This is a general one if you
Yes.
either double-decker or single, whatever.
Yes.
It's a continuous one. That is very specialized. With the manufacture of those mobile cross-sections at this side only. Of course, that's good because, see, Brahmaputra, I don't know how many of you, when I take about how many, all your rivers are all female rivers.
Only last week when I went for a Indian Rose Congress seminar, they told me, sir, this is, and it is more dangerous. Because it changes the track like a mail, anytime, anywhere it goes up. And it is very difficult because every time there is flood or heavy movement, it brings in lot of sea and post there. And it is very difficult for any bridge engineer to build a bridge there. Brahmaputra. Built on Brahmaputra, if you can build a bridge across Brahmaputra, either design or construction, you can build a bridge anywhere in
The world. That's true.
It is so difficult that they say that the beautiful engineers there, and time allowed is hardly about 50% of the total yearly time, and water depth is more than 50 meters, very difficult. Sinking, in fact, our PWD, they wanted to remove that schedule of red star for this well foundations. I don't know how many are there. They wanted to remove the well foundation schedule of rates itself. And I told sir, don't remove the Jayprakash, don't remove that. Because when I checked there in the Assam PWD, well foundations are prominent like what you do by here. And excellent, yeah, economical, excellent work is being done. That's the way this Brahmaputra bridges is. Since I am we are conducting IABSE here, I have already started some engineers, if they come in group, can you allow them to have a look at your bridge? 2 bridges are in progress. And that executive engineer told me, sir, kindly send them here. I will very happy to explain. Gujarat engineers have already gone there. Gujarat engineers went there, they saw, and whatever possible they try to implement. I don't know how many of you are interested. Bring them to the group, and you can call up Arvind sir.
How can we switch it on? The screen needs to be switched on. No, it's connected, remote.
Yes.
Okay. So we have had quite a lot of discussion about Sophistic, its capabilities, and it's time to have a hands-on experience. Because we have about 2.5 hours at hands. So having the full automation would be difficult, but certainly let's try how much we can cover. I was thinking of having a simply supported beam example just to explain the whole workflow, but I believe I'll skip that and we'll directly head on to the development of automation of a PSC composite bridge I mentioned in my presentation. So this is what we are going to do: definition of axis placements, creation of the geometry, apply the loads, and see how it is controlled from the axis and placements. So everyone, please start SSD 2025. You must be having a shortcut on your desktop. Please start SSD 2025. Please start SSD 2025. It will ask for a new project. We need to create a new project. When you're creating a new project, please make sure that you save the project in a folder, not on C drive, not on Google Drive, not in OneDrive, otherwise the analysis speed will be slowed down. So just save it in any drive other than C, OneDrive or Google Drive. Alright? So please save it in a folder and give your project a name. After we have specified the path where we want to save our project, just choose IRC 112. Selection of code here is just for material and section property definition. We can change it at any stage, and it's not necessary to use these codes only for the purpose, but we are going ahead with IRC 112 for material and section properties. So just select IS over here, IRC 112 over here for the purpose of selection of material and section properties. So we are going to select the concrete, pre-stressing steel and structural steel from IRC. By default, the system is 3D and gravity is in the negative Z direction. So the sign convention is same as AutoCAD. XY will be horizontal, Z will be vertically up. Okay. So these are defaults. You don't need to change anything. Just select IS, IRC 112, and then comes the unit part. We are setting the unit system over here, but we can change unit at any stage in our project. Over here you can see unit set. I'll move it slightly up so that you sitting at the back can see. So under unit set, you might be having metric system written over here. If it is metric, change it to structural engineering and click OK. You must be having structural engineering unit system selected. Structural engineering unit system will mean that our cross sections will be created in millimeters and we'll be working with meters for creation of the geometry. So this is the common unit system that we use. We can change unit at any stage. Even in the results, we can change units for extraction of results as well. So this is just a global unit that we are setting. So I'll repeat. We have specified a folder, given a name to our project to save it. We have selected IRC 112 for material and section properties, and we have selected the unit system structural engineering. Okay, please make sure it's not metric for anyone. Let's click on OK. A new project opens inside Sophistic. Yes. May I see? And this mouse is not connected to. We can take out the mouse and use it. No, it's not being read. Have you activated the trial license? By entering the code? Okay. You're not using that? But installing here Unless you have Sophistic installed, it cannot read the license file. So Sophistic is not installed here, right? Yeah, installation will be required first. Since the software is installed here, I would suggest you use it here, sir. We'll help you with the installation in this system afterwards. Okay. So just Siley. Unable to log in with the official email ID on this computer. Can we give the license file somehow? Okay, so let's proceed. We have opened a new project. Hopefully it's open for everyone. As we have seen in the presentation, we are going to use, let me firstly introduce the interface to you. At the top, you will see a ribbon menu. This ribbon menu gives us an option of post-processing. So under post-processing, you will see there is viewer. Viewer is currently open. There is system visualization. These are just two different options of viewing the model. We'll be creating the model. There are two ways of viewing the model. Either we see it in viewer or we see it in system visualization. So two options to view the model. Then there is graphic for seeing the graphical results. There is result viewer for seeing the tabular results, and there is report browser for extraction of report. So these are the post-processing options that we'll be using afterwards. In Sophistic, we are going to analyze the structure, and since we are performing the analysis in this interface, we'll be using the tools on the left. So if you see the tree menu on the left side, it's the project navigation tree, or also known as the task tree. In this, there are tasks for adding material properties, adding cross-section properties, then performing the analysis, live load. Now you might feel that, okay, these tasks are limited, we might be needing some more tasks, or maybe some tasks are of no use to you. So you can simply right click in this task tree, go to insert task, and you can choose from the list of tasks that Sophistic offers. So whichever graphical task you want to use, you just choose that and add it to your project. Currently, I'm not interested in adding these tasks to my project, and since we are going to perform just the modeling part, we are not interested in analysis. We'll be having time to see the automation only. So I'm removing these tasks where I'm performing the analysis as well. I'm just having the modeling done, and we'll see how we can automate our models. With that overview, to delete, I just press delete from my keyboard. Even if you don't delete it, doesn't make a difference. You can keep as many tasks added as you want. Sophistic will analyze only those tasks which you are giving information to. Am I going fast? Should I speak slow? It's fine, right? Okay, so let's begin with modeling, and we'll go to Sophie plus X. Just double click and Sophie plus X will start. It might take time because if it's opening for the first time, it does take some time. If anyone has any problem opening Sophie plus X, please let me know. Is it open for everyone? निकाला था sir. Is it working for everyone? No issues? All right, perfect. So as we can see, as I mentioned earlier, yeah, Sophie plus X still waiting. Few systems are slow, so we experienced that yesterday while we were installing. These systems are compatible to Sophistic's requirement because minimum requirement is 4 GB RAM, Windows 10 or higher, and Core i5 or higher. So systems are compatible, except for those 4 computers at the back, rest all are compatible. So if it's open, you can see this is AutoCAD. In the time it's open, is it open? Not yet. Can I connect to a different internet, sir? It's too slow for my mobile. Civil 7? No. Shall I try? It's connected. Is it open now? Not open here? I think we'll leave this system. How many systems who are not having Sophie plus X open yet? 1, 2, 3, 4, 5, 6, 7, 8 systems. How can we help? AutoCAD is taking time to respond. Maybe you share with someone else, share the screen with someone else, because if AutoCAD isn't responding, it's taking time to respond, it might take even more. Let me see if there is anything specific that's... Okay. Just press cancel. Sophie plus X is already open. Any other system? Where? Okay, I can see waiting for Sophie plus X to start up and cancel. Just press on cancel Probably Sophie plus X is already open. Look at the window at the bottom. There will be Sophie plus X. Yeah, no, start Sophie plus X. Start Sophistic. Alright, so it is open. Anyone else? Okay, so it's open for everyone now. We can continue. The first thing here that we see is this is perpetual CAD, like I mentioned, and apart from CAD tools, if someone is unfamiliar with CAD, let me tell you, this is the view cube through which we control the view, and if you are in any view, you can just click on this home button going to the isometric view. So clicking on this home button can take you to the isometric view. Let's say you zoom in somewhere and then you're lost, just click on home and you'll get back to the original view. This is a saved isometric view in AutoCAD. So that is about viewing. For snapping, let me tell you that there are snap tools. So next to this square, there is an arrow which can take you to object snap settings, right? Those who are unfamiliar with CAD, for them I am telling. So you can click on this arrow, go to object snap settings and make sure that all snap settings are on. Those are pro with CAD, they can choose the snap setting which they need at any stage, but if you are first timer to AutoCAD, I suggest that you keep all snap settings on. Okay, so I repeat, next to this square, you have this downward pointing arrow. You click on object snap settings and click select all. Keep all snap settings on. Okay, so that's about snap setting, viewing. Now on the left, there is a tree menu added within CAD, which is Sophie Plus. This Sophie Plus tree menu has got system. System tab gives us the option to define materials, cross-section properties, pre-stressing system, axis. Structural elements tab is used for creating the geometry. So we create the point, line, area from here. We go to the loads tab to apply the loads. We go to pre-stressing tab for applying the pre-stress. So this is the general workflow. We go from top to bottom. We start with system. We go to structural elements, apply the loads, define the pre-stress. Then we export the model to Sophistic, and messages tab gives us any errors or warnings when we are exporting the model from CAD to Sophistic. Filter is for selectively isolating part of the structure. In case you are not interested with all the elements, you are just willing to edit few of the elements, you can filter out those elements and work with them. Tools is just to control the display of the model. Let's begin with system, and the first thing is adding material and section properties. Now what we are referring to is a tutorial that's available on infraserviceof.com. So hopefully everyone has opened infraserviceof.com. If not, please go to your browser and open infraserviceof.com, the website that I shared in my presentation. It's a partner company of Sophistic. Through them we have registered our business operations in India, and we upload all our learning materials over here. If you go to YouTube, you might find lesser materials of Sophistic because American German company concerns, so let's not get into that. But all the learning materials of Sophistic you can find. It's a one source for all learning materials of Sophistic. Let's go to learning materials and we'll go to Sophistic. Here you can find self-learning step-by-step PDF tutorials, video tutorials, certification courses, text examples. If you're interested in the text interface, then there are few YouTube videos, beginners tutorials, TEDdy training, and then there are customized verification examples and customized trainings as well. So we'll go to the PSC Composite Bridge tutorial. This step-by-step PSC Composite Bridge tutorial, will click on download PDF tutorial. Going to infraserviceof.com, we'll go to download PDF tutorial. Okay. This is the website that you need to go to. Are we inside the tutorial? Anyone who is having any problem? No one. Okay. So here what you will find is, it's a step-by-step, as I mentioned, it's a step-by-step PDF tutorial. So you will find that the first step is to download the GAD, which you are going to use to create the model. We don't need to do that. We are not going to download the GAD, but in this tutorial, this is a GAD based tutorial. So firstly the GAD will be downloaded. Then we will define the system related information, material properties, section properties. Then we will convert that GAD into structural members, and then we will define boundary conditions, apply loads, pre-stress. So this is how it goes on. Now what we are doing is, we are skipping the GAD based approach and doing it using the axis based approach. But the first part, which is the definition of properties and material and section properties, we are not going to do it. So let's go to the page where cross section property definition is completed. Is still cross section property definition. Okay, here. So at the end of step 3, before the starting of step 4, there is a note. If you face any difficulty creating cross sections, you may download this CDB file. What we are going to do is, we are not going to through the steps of creating the cross sections from CAD. Instead, we'll just use this CDB and import the material and cross section properties. The reason being, of course, time is one of the concerns, but if you are interested in understanding how we can create cross sections from CAD, you have this tutorial as a reference. You can just follow step by step. In these first 11 pages, the creation of cross section has been discussed, material and cross section properties. Let's download this cross sections.cdb. I'll keep it on my desktop so that I can easily access it. Please download it, and then I'll guide you to the next step. In the time everyone is downloading, if you can just have a look at the screen. Adding materials is pretty simple. You just right click on materials and go to the new material from design code. You choose the material grade. If it's a standard concrete, you choose the grade of concrete which you want to define, choose the type of cement. For pre-stressing steel, you just choose the pre-stressing steel. You choose 1600 yield strength steel. If you have a reinforcement to be defined, you just select the grade of reinforcement classification, and then you can just have all the strength parameters as per the code automatically entered. So it's all available in the database of the software. The moment you select the grade of concrete, compressive strength variation and creep shrinkage are automatically defined. So there is no separate definition of compressive strength and creep shrinkage as such in Sophistic. I just briefed you. My intention was just to let you know that this is how we do it. Just right click and add a material. But to save time, we are not going to do it together. Instead, we will delete the default materials which are added. There is no material anymore in my project, and I will simply import. Has everyone downloaded the file? Anyone who is still downloading? Okay, so everyone has downloaded. Let's right click on cross sections. Let's right click on cross sections and go to import. We are right clicking on cross sections and we are going to import. I repeat, right click on cross sections and go to import. After clicking on import, there is a folder icon here. Clicking on this folder icon, please browse to that cross sections underscore pre-stressing system file. Do I need to repeat? You're not? Okay, close it, sir. Okay, close it, sir, close it. How come it's not showing anything? Why? Is it not working for everyone? It's working. It's working for you. It's working for you. For whom is it not working? But everyone has the same software installed. Version license, which license have we given? Which license are you using? The 10 days license, trial license. And which license are you using, ma'am? No. Did you activate the trial license or you downloaded the file from your email? From your email. Okay, so seems like importing option isn't available in the trial. Okay. Okay. Click OK, please. What to do? Cancel. Okay. Those who have activated the trial license themselves by entering the credentials and entering the code from the email, seems like import option isn't available in that. So have you also used the 10 days trial license that we shared on email? Okay, so for that it's working, but for trial license it isn't working. So sorry, my bad, didn't know this. So can you just cancel it and close Sophistic, save everything, close it. It will just take a minute. Everyone has the license file on their email ID, right? Everyone has their license file on their email ID. There was a license file shared on email as well. Siley, it was shared with everyone, right? To everyone's email ID. So there is a license file shared on your email ID. Please activate that license and it will work. It's working for you, working for you. Save it, close it and then just close it. Yeah, Siley has sent an email as well, right? For the license file. She hasn't received it. Maybe her email ID was incorrect. Email ID change check kar lo. Okay, fine. Yeah, you can use the same file as well. Yes, the license file that he has. Yes. Yes. You can just forward the license file to him and he can use it if he hasn't received it. Okay, fine. Is there an Okay. We'll take 5 minutes break. So it's working after you have activated the license. It's working. You just open your project and then you are able to import. Those who are facing difficulty, just stay back. I'll help you. We'll take a 5 minutes break and then we'll resume. For them who are having the systems already working fine, you can just go for the break. Okay, we'll have to continue now. Saili, after you're done there, could you help two people over here? Just two. Okay, so what we are doing now is, we have got a database with us from which we are going to import cross sections. It's an already completed project from which we are importing. So we'll import end diaphragm. When you select end diaphragm, you have to click on this left arrow. It comes into the import dialog box. Likewise, we have to import the intermediate diaphragm. We'll import the mid girder and the end girder. So you have to select the section and click on this single arrow. Then this section will come over here. We have got 4 sections over here. These 4 sections will be imported. So it's a list of sections that we are importing, and along with that all materials will be imported. So we are not going to add materials as well. Along with cross sections, all materials will be imported. It can be used in case you are using the same material or cross section from your previous projects as well. You can simply import using this approach. Anyways, we are doing this because we have skipped the part of creation of cross section ourselves, and we'll click on OK. Please just import these 4 cross sections. So you should be having M40 grade concrete, 500D reinforcement, M35 for the deck, diaphragm and deck, and one more M35 for the zero weight of the deck. There will be composite section modeled. So there will be deck in the composite section, and there will be plate element for the deck as well. To avoid the duplicacy of the weight, we are adding a zero weight material as well. So we have added materials and we have got cross sections. In the time you are importing, I'll just show you the cross sections. This is the mid girder cross section created simply from GAD. So if in the GAD you have a cross section available, by the way, in black background it's not quite visible. Yeah, can we switch off this light? That will be better. छोड़ दीजिए सर, we don't know. Shall I try? So projector ना बंद हो जाए. Some switch. So basically we have got the CAD cross section converted into a cross section over here for the mid section. Likewise we have the end girder cross section. And usually when we are dealing with composite bridges, we design it for bending and shear, and we avoid the torsion design. If you have a practice of torsion design, please go ahead with the default approach. But in Sophistic, just for your information, I am telling you, there is an option to go into cross section properties, and you can go to additional properties. You can give torsional moment of inertia factor. We give a factor of 0.001, then the girder will not have any torsional moment of inertia. All the live load that will come which generates torsion will contribute to your bending and bending majorly, and it will not go into the torsional forces. Since we are not designing it for torsion, it's better to keep it as 0.001 so that it does not take any torsion. Otherwise, you might be under designing your section. Okay, in common design approach for composite bridges, we don't design composite girders for torsion. We usually design it for bending and shear. And we say that, okay, if it's passing it, it's all okay. Alright? What happens is, especially live load generated, there is force coming in the girder, but we are not considering that force for the design. So we are ignoring the torsional forces, which is incorrect. So either you go for the torsion design, if you are just using the normal approach of creation of cross section, or you have the option in Sophistic. Sophistic gives you this option. In other programs, you can't remove the torsional stiffness if you are using the database sections. But here Sophistic gives you an option that just for torsion you can give a factor, so it will not have any torsional stiffness, and then your bending and shear design is okay. For curved bridges it becomes important to consider that, sir. I agree with that, but for straight we are still seeing just bending and shear and going ahead with it. It's there, sir. It's dependent on consultant's choice as well now. So I just told you that this is the approach to meet everyone's requirement. Yes. So we have added material properties, cross-section properties over here. Everyone has imported. Now we can go ahead to prepare the geometry. But before that, we need pre-stressing system as well, because we are going to define pre-stressing steel. So let's right click on pre-stressing system and click on import. We'll browse to the same database and import the pre-stressing system. Only one pre-stressing system is there, 19K13. So we'll have 19 strands. All right. So 19K13 is the only pre-stressing system. I'm importing the pre-stressing system as well. So you can see a pre-stressing steel has been imported in here. Should I repeat? You have to right click on pre-stressing system and go to import. Okay. Browse to the database from which we have to import the file that you have downloaded. Select that and move 19K13 towards the left and click OK. It will be imported. Okay. That is by default 0. In case there is some pre-stressing system, let's say you are working on a project, you have added 5 pre-stressing systems and you say that, okay, I have got 4 more pre-stressing systems to be defined. Those are already available in some other project. So you can give an offset, 5 are there, it will be added from 6, 7, 8, 9, 10. So for that purpose, an offset is there. Shall I repeat? Have you right clicked on pre-stressing system, sir? Have you gone for the import? Have you browsed to the database from which we have to import? Please click on the folder icon and open the CDB file from which we have to import. Is it added? Is it added here? Silent. मुझे सुनाई नहीं दे रहा है. Okay, so we have got material properties, cross-section properties and pre-stressing system. Now once we have imported the system related information, it's time to create the axis. Okay, and this axis creation, like I said, if you're using the GAD based approach, it's not at all required, but we are creating axis to have an automated model generated. This automated model will serve the purpose. If I create the axis based model today, I'm not going to start from scratch for any composite bridge of single span ever in future. Whether it be deck continuity or a simply supported PSC composite bridge, I'll just use this model, make some changes, 15-20 minutes if I'm a beginner, if I'm an expert, 5-10 minutes and have a new model immediately ready. So that is what we are going to create. Please pay attention. I know I can see some drooping shoulders. Please pay attention and let's proceed forward. So we'll right click on axis and we'll click on new axis. Any problem here? Computer is not responding. I would suggest you share with someone else if it's slow. We'll click on new axis and we'll create an axis like we saw in the video. If it's a composite bridge, we have an axis for the girder and another axis for the deck. So let's create an axis for the girder first. Axis for girder in span 1. Usually this is how we name it. It's your call. It's completely user's choice. But we name it as AGS1, AGS2, AGS3 for multi-span bridge as well. So we'll have for span 1, span 2, span 3, we can handle multi-span bridges. So AGS1, axis for girder in span 1. This is what I am creating. And I'll click on OK. Now we have to enter the length of the girder. Let me check the tutorial. What's the length? I'll just refer to the GAD over here. (1.05) plus 1.75. We are going to make this curved skewed PSC composite bridge by making a straight bridge first. plus 15.5 plus 1.5 plus 1.75 plus 1.05. Total length is 24.1. So I'll make some adjustments. This is 1.05. I'll keep it as 1 meter on both sides, and then we'll make 24 meter model. So let's enter the length of the axis as 24 meters. 24 meter is the length of the axis that we are creating. I'll click on OK. AGS1 has been created. Length of the axis is 24 meters. Any problem? By clicking on the home button, I have got the complete view of the axis. Okay. Now once we have created the axis, you will not have geometry debugger in your system. This is for developers only. Horizontal alignment, as we can understand, it is to make the axis curved. We are not going to have a curved model prepared at first. We are modeling a straight bridge in the beginning. Vertical alignment is for curvature in the vertical profile. We are not giving any vertical alignment, but placements are necessary. So let's go to placements and define placements. Please pay attention towards the screen how I am defining placements. So if we see the drawing, what are placements? Like I mentioned, placements are the crosshairs which store the information of the substructure. So definitely I need placements at the bearing locations. Also I need placements where my sections are changing. So end section changes to tapering, tapered section changes to mid section. So at the interface of these sections, so I'll have a placement here because this is the start of the girder, then at the bearing location, then at the end of the end section, then at the end of tapering, at the middle as well because we need one placement for the middle diaphragm, then a placement here, here at the bearing location, and then at the end of the girder. So these many placements we have to define. Let's enter those placements. So to define a placement, the first placement will be at 0.5 meters. I am taking 0.5 meters because I am taking this width as 1 meter and I am assuming that 0.5 meter is the overhang of the deck. So I am taking the start of the girder as first placement and this width is 0.5 meter. So girder will start from 0.5 meters in my 24 meter axis. Fine? Clear? Now the next placement, I don't want to enter 0.5 and then calculate the distance for each and every placement. I want to give relative distance. So what I will say is from P1, the offset is 0.5 for P2. So P2 is 0.5 meter ahead of P1. So I can have the placement for bearing. Right? So I have defined first placement, then 0.5 meter is the distance to the bearing, and then from here 1.75 is the offset to the end of end section. So I'll add another placement. From P2 it is 1.75 meters. After 1.75 there is 1.5 meter tapering. So I'll add another placement. From P3 1.5 meters will be the end of tapering. After tapering it's 15.5 meters for the middle girder. So we'll enter from P4 it is 15.5 divided by 2, 7.75 meters. Yeah, again 7.75, correct. So from P5 it will be 7.75 and then its mirror image. So from P6 it will be 1.5 meters. From P7 it will be 1.75. We are at the diaphragm location, diaphragm or end bearing. 8, after 1.75 we have 0.5 meters. So total length of the girder is 23.5 meters. that is overhang, so I don't need a placement. My girder extends from 0.5 to 23.5 meters. Total length of the axis is 24 meters. That is from EJ to EJ, expansion joint to expansion joint. So my deck will be from 0 to 24. My girder is from 0.5 to 23.5. 0.5 meter excess on both ends. Do I need to paste it in Word if it's not visible at the back? Let me just copy this one. Please let me know if it's done for everyone. We just have to enter this. We don't have to enter these distances. We just have to enter from which placement how much distance you want to specify for the placement. Anyone who is still defining it? Okay, I'll wait. Is it done for everyone? Anyone who is still defining it? Okay, we can't wait then. You can copy paste this data from Excel as well. I have seen consultants for extra dose bridges where there are segments and then lot of data is there. For each and every placement, they create everything in Excel, putting a formula and then just copy the whole table and paste it here. So that also works. It completely the end user's choice. Okay, fine. Okay, great. What happened? Lost somewhere?
Yes, no. Like that I am doing something.
Okay. What happened?
change the delta.
You are inside cross section. Have you imported some cross section? Why is it? Close it. You have SSD open, right? Why is this open? From SSD, open Sophie Plus. It's fine. Have you created the access as well? Okay. Some of you made the mistake of keeping the unit in metric, so that's why you got it in millimeter. You have to change the unit system to structural engineering. Because of millimeter, you created a 24 mm girder. That's the mistake. Yes? No, you have to, you have not created AGS1. Now I'll have to proceed. Try to catch up, okay? Wait, it will ask you for length. Type 24 meter here. Now define placements. We have already defined. Take her help maybe. Okay, so we will proceed. We have added the placements over here. Is there a support at 0.5 meter from the start? No, right? It's the girder start. So there is no support. We need to change this to excess at start. And the last one will be excess at end. So first one is excess at the start and the last one is excess at end. Okay? Support will be there at 1 meter from the start and 1 meter from the end. So we'll keep these two as support. In between, all these placements are just for indication of change in the section definition. So we'll select all of those and change from support to none. So we have got excess at start, support, none, then support, excess at end. So this is what we are specifying for the placements. These placements will help us create the geometry and control the length of the tapered section, the end section and the mid girder as well. So if I want to increase the end girder length, then I can just move the P2 placement ahead from 1.75 to 2 and the end girder length will be increased. So this way we can control everything. We are creating a model where we can control everything and create the project as per our requirements from project to project. Any questions? Yes, ma'am? This one? This is from here. This is where the girder is starting, right? Yes, extreme end. The next one is from here. From P1, P2 is 0.5 meter ahead, which is the bearing location, the end diaphragm. And then we have given 1.75 for the end of the end section. Then there is 1.5 meter tapering. Did you get that? So it's basically the girder distance from start of the axis. Axis is from expansion joint to expansion joint. Okay, so we'll click on OK. Definition of axis and placements is done. Now this axis is for the girder. There will be one girder in the middle. We are having three, let's say 3 girder system. Okay, let's create for 3 girder system. We have got one axis over here. We need more axis. So what we'll do is we'll create secondary axis. Center to center distance between girders, let's take it as 2.9 meter. So we'll right click on secondary axis, create with offset. I'll enter a distance of 2.9 meter. I'll click OK. Again I'll right click on secondary axis, create with offset. This time I'll give minus 2.9 meter. So we have got 3 axes now. There is one primary axis with all placements, there is secondary axis. This is the most crucial part, creation of axis and placements, because this is going to control everything that we are going to do next. And for future as well, only changes we'll make will be in axes and placements, will not touch the geometry at all, or the boundary, or the loading, unless the magnitude of load changes. Yes sir, simply right click on secondary axis and choose create with offset, enter the Y offset. We want to translate in the transverse direction, so just entering the Y offset gives me another axis in the transverse direction. Yeah, sign convention is XY is the horizontal plane and Z is the upwards direction. X is along the girder, Y is in the transverse and Z is vertically up. Okay, can you close this sir? Save. Okay, now here sir, secondary axis. Oh, just a second sir. After 0.5, do we need this? 23, no see, 0.5, 1.75, 1.5, 7.75, 1.5. 0.5.
Need another station for support at 24 meter is
Your starting point is incorrect. You have to start from 0.5. That's it. Everything is correct. Okay. Now you can close this. What happened?
that was the main axis. No, I'm doing this.
Yes, sir?
Once you delete, it's gone.
You made a mistake of creating the axis inside the cross section. I should not have explained the cross section because clicking on that created axis inside the cross section drawing. That was my mistake. It shouldn't be done. Okay. Can you create placements, please? 0.5 will be the start. From P1, can you type now? P1, switch on caps. 0.5. Refer to the drawing and just enter some distances, sir. Yes, sir. Any questions? Yes? No, we are not dealing with vertical alignment. We'll keep bridge horizontal. We are not giving the vertical alignment to the bridge. Yes, 24 meter is fine. What about the placements? Where are the placements? Okay, please. Okay, I'll proceed. Okay, so we have got one primary axis for the girder and we have got secondary axis created as well. Okay. Now only thing that remains is having an axis for the deck. That is the only part that we need for the automation. So please right click on axis and click on new axis. Again I repeat, please right click on axis and choose new axis. This time we'll create an axis for the deck. You can give it any name. Usually deck is continuous, so we create single axis for the entire deck. Just give a name to the axis and click OK. I think some were unattentive. I'll repeat. So we have got AGS1 created. We have given the horizontal alignment 24 meters. We have defined placements and we have defined secondary axis for two other girders. I'm right clicking on axis, choosing the new axis and writing AD for new axis for the deck. Deck length will be again 24 meters because from expansion joint to expansion joint we'll have axis of the deck, and I'll click on OK. Axis for the deck is defined. Now in axis for the deck we will need placements. Everyone, coffee is ready at the back side. Please get the coffee and come back to your seats. We'll continue with the workshop, but just we'll take a couple of tea, coffee and snacks are available on the back side. We skipped the vertical alignment part. We went to the placements, assigned placements to the girder. Now we are assigning placements to the deck. There is only requirement at start and the end of the deck. There is no other placement, no changes in the depth of the deck. So we'll just keep these two placements. These are not supports, so we'll just change them to none. We need to have placement so that the software knows where the deck starts and where it ends. We'll just have placement at 0 and 24 and assign them type as none. That's it. We'll click on OK. Placements are done. Do we need secondary access for the deck? We do, because we'll have crash barrier here of 0.5 meter width on both sides, and in between we have the carriageway width. So what we will do is we'll create secondary access. Let me measure the deck width. .2 meter is the carriageway width. So we'll create secondary access. Right click on secondary access of the deck, create with offset. 8.2 meter is the carriageway width, so we'll go 4.1 positive and 4.1 negative, making 8.2 meter width. Okay, so we'll create secondary access at 4.1. Okay, another secondary access at an offset of minus 4.1. 4.1 minus 4.1 is done, and then the crash barrier width is 0.5 meter, so we'll add 0.5 to 4.1 plus 4.6 and minus 4.6. So we'll create another secondary access, create with offset 4.6, okay, and another secondary access of minus 4.6. So you can see we have got 4 secondary access created here. If I show you from the top, there is one central deck access, then there is secondary access here and here, likewise at the bottom. On both sides we have got secondary access created. That's it. This is the major chunk of the work if we are doing the automation. We have got the access and placements created as per what we need. Now is the time to just use it and create our geometry. Is it done for everyone? Okay, so we have got secondary access created, and now we'll move to structural elements to create our geometry. To create the geometry, you will see that there is point, there is line, and there is area. This is what we can create. Firstly, we want to create girders. So what will we choose? Line. Yes. So let's click on line. Let's click on line command. From the element type, we'll select beam with reference axis. So whatever is the offset given in the cross section will be used for my beam elements that I'm going to create for girders. So I have clicked on line and I have selected beam with reference axis. I want to create girder, but girder has varying section. There is end girder, there is mid girder, and then there is tapering as well. So for a start I am choosing end girder. Only 2 things you need to do. One is choose the element type, beam with reference axis, and then choose the section. So we have just selected the end girder section. So these 2 things, and that's it. Have you chosen? Yes sir. Have you clicked on the line command, sir? In that case, you might not be having the sections imported. Have you got the sections imported? Please do not press escape. Just for her, if you go to system and check your cross sections, are you seeing the cross sections here? You ma'am, are you seeing the cross sections? You need to import the sections and then you can create the beam element. Yes sir. Have you got the secondary axis created? You're not having the sections, right? No, you imported the wrong sections, ma'am. You needed to import the mid girder, end diaphragm and intermediate diaphragm. You maybe imported the other sections which were at the bottom. Maybe just have a look at the screen from the person sitting next to you and import the correct sections. Yes, sir? You added the secondary axis, right? You go to structural elements tab to create the geometry now, and I have clicked on the line command. Only two things, beam with reference axis, and selected the end girder. Is it done? Now in AutoCAD, whenever we are working, all we have to do is, once we have entered the information here, we just need to look at the command line. In command line, there are many options. These options can be handy when we are working with GAD based approach, but since we are creating an automation model, we'll want to have everything attached to our axis. So we have to choose the option of segment on axis. Segment on axis. Okay. After clicking on segment on axis, I'm going to click on, you can see there is AGS1. I'll repeat. Okay, I think some of you will make mistake if I click like this. It's better press escape. Please press escape, get out of the command. I'll tell you a different way, otherwise there might be some of you who might be making mistake. So please press escape. What will happen is some of you might click on the axis for the deck and it might be a problematic thing. There is axis for deck and there is axis for girder. Both are here, right? So what we want to do is, we don't want to use the axis for the deck for creating our geometry. So we'll select the axis for the deck, right click, isolate, hide objects. I'll keep the cursor here, please do this. Select your axis for the deck, right click, isolate, hide objects. This is the AutoCAD feature of hiding anything that you don't want to see. This will avoid mistakes. Yes? Okay. Are you here? Have you got the axis created? I'm just selecting the axis for the deck, the smaller circle. Right click, isolate, hide objects. I pressed escape, so it doesn't matter what you did. I just pressed escape, got out of the command. So this axis for the deck needs to be hidden, otherwise some of you might click on the deck axis and then girder will be created at the deck level. So we'll select the axis for the deck, right click, isolate, hide objects, and then we'll have only AGS1 available in the center. Now we'll click on the line command. Same thing, beam with reference axis. We want to assign the end girder section. I want to assign the end girder section. From the command line, choose segment on axis and just click on the axis. You can click on the axis anywhere. So if you click on the axis, it will ask you, do you want to create element between all placements? Just say yes. Likewise, create on the other two girders as well. Just click on the axis and choose between all placements. This way you can create girders at these three lines. So these are the axes for the girder. We are creating lines on all these axes. Just click on the axis anywhere and just choose between all placements. Is it done? Okay. To get out of the command, we just press escape. We have got girders created. Now let's create the deck. Girder is done. Now let's create on area. We'll go to the general tab. We'll go to the general tab. After clicking on area, we are going to the general tab. Thickness of the deck slab is 230 mm. So we'll type 230 mm. Material for the deck is M35. We'll select the material, we'll select the thickness. There are meshing controls as well which we will not use. Support and bedding options are there, geometry offset is there. So after going to geometry, after clicking on general, giving the thickness of 230 mm and selecting the M35 material, we'll go to geometry and give an offset to the thickness. There is a composite section that we are creating and the deck should be overlapped with the plate that we are creating. So we'll have to give negative local Z offset. Is it clear or do I need to explain? Do I need to repeat? Okay. The area command or the previous one? Have you created the line elements? You just click on the axis. Shouldn't be the case. It's straightforward. Just click on the axis and it should be created. No, you don't need to select. Okay. See, after you enter the here, segment on axis, you snap settings. There is some glitch with auto. Okay. Click on line command, beam with reference axis, and how many sections? End girder section, segment on axis. Now there is some issue in CAD.
That's what it's not picking the recognition.
Snap settings. Yeah, it looks like that, some snap settings. What should be allowed?
It's picking only.
Maybe AutoCAD, the systems are not that good. Close it, open it again, then check if it is allowing you to snap. Try it again, sir. Maybe it will allow you now. Okay. Try it again, clicking on it. Yes? You made a mistake. Isolate, end object isolation. You have to hide the deck. No. Escape, press escape. Now you create the elements. Okay, go to line command and create the elements. Okay, we don't have much time, so we'll have to go a bit quicker. We have created the axis, we have created the girder elements. Now we'll create the deck. So we'll click on area. Under general tab, we have given a thickness of 230 mm. Material will be M35. M35 material for the deck. Geometry, I'm giving negative Z offset. Now the area that is to be created is again using the axis. So we have to choose the option from the command line, segment on axis. So whenever you are creating the geometry, you have to choose the option from the command line. Whenever you are working in CAD, you have to choose the option from the command line and then only execute it. Okay. So I have chosen the option of segment on axis and just click on two consecutive axes. Just have a look at the screen first. I have clicked on this axis. Now I am clicking on the inner axis and I'll choose between all placements. An area has been created. This will be for the crash barrier. Again, I'll click on the inner axis and the other side inner axis and create the area for the carriageway. Again, I'll click on the inner axis and the outer axis between all placements. Another area has been created. So we have got three area elements here for the deck. Right? So we have created girder elements and we have got deck created. Deck has been created for crash barrier and the carriageway. Let's press escape to get out of the command, and if you want to see your model in 3D, just change the 2D wireframe to conceptual and visualize your model. So there should be proper what happened? Did I not have the correct sections? Okay, fine. We haven't changed the sections yet, right? We have assigned the end section to all the girder elements. Shall I just demonstrate, sir, because it seems like we won't be able to cover everything if we are going with the hands-on. This part won't be in the tutorial, but I can share a recording. But what I feel is, no sir, there is no place. You have activated girder in the deck. Where is the girder? The offset was mistakenly entered, sir. There are 3 girders. The deck shouldn't be this wide. There should be deck nearby. So the offset was quite large. You have quite long cantilever. And the deck was to be created here, one for the carriageway. So from here to here.
That is 2.9 meters.
No sir, from this end of the crash barrier to this end of the crash barrier. So that is the only 3 area elements. That is one. Press escape, sir. Click on this and click on the other side. Yeah, between all placements an area has been created, sir. So 3 area elements have been created. I think it will be better if I just go ahead with the demonstration. Have a look. I'll share a recording. I know the time was, we have lost time. So I'll just demonstrate. Is that okay, sir? I'll just demonstrate from here. All right. I'll share the recording of this, so it will be better. Yes. So what I have done over here, just have a look at the screen. What I have done over here is, we have assigned the end section to all the elements, but these elements which are in the middle are supposed to have the mid section assigned. So I can simply select it. I created them using the line command. To edit it, I can just use the edit line property and change from end section to mid girder section. Now here there are elements which are tapered. So they are no more having the end section or the mid section. So I'll again edit those properties. The start section will be end girder. The end section will be mid girder. I'll click OK. It will be tapered from end to mid. Likewise on the right side, there will be tapering. I'll select these lines, modify the property. Start section will be mid girder, end section will be end girder. So tapering will be from mid to end. Doing so, I'll show you the conceptual view now. You can see the conceptual view. This is the tapered profile now. So we have got the end section, the tapering, and then the mid section in the middle. It's this way we can modify the properties. So just to repeat, you just double click, you can modify the properties of single elements. If you are willing to modify multiple elements, you select those elements. You can multi-select elements in CAD just by clicking on those elements. And to modify it simultaneously, you use these modification tools on the right. So girder is done, deck is done. Now let me create the diaphragm. Diaphragms and bearings are usually associated with placements. So placements are something that we have created over here, and this blue placement is highlighting that this is the support placement. Diaphragm and supports will be placed at these 2 placements. So what I'm going to do is, I'm going to double click on this placement. I want to create a diaphragm here. So I'll click on line command. I'll select the beam with reference axis. I'll select end diaphragm section. I want to have end diaphragm created over here. Once we have entered the information here, we choose the option from the command line, single element mode. I'll create from midpoint to the midpoint. An end diaphragm has been created over here. Now end diaphragm is done, but this grill edge which is at the top of the girder level needs to be connected to the support. So for that we'll go to point and I'll create support. Sophistic gives us both options. We have global as well as local. Local is advantageous because later on this is an automation model. Later on it can be curved, it can be skewed. We always want the support to be tangential to the girder. So if you use local, it will always stay tangential. Otherwise, if you use global, like other programs, you will have to rotate the local axis of the element or local axis of the support. Okay, so that is why we don't recommend global. Here I am again going to use the local support, and I am checking on px, py, pz, mx. Checking on means constraining. So I am constraining the 3-direction translation. I have constrained torsion just to avoid singularity. If you want, I can uncheck this, but when only the girder is activated, at least the torsion should be constrained. So px, py, pz, mx, these are the degree of freedoms that I am constraining, creating a pinned support. I will model it by snapping at the bottom of the girder. It's done. Diaphragm is there, support is there. It needs to be connected. For connecting it, what we use is, so we used point. Point is for point supports or point springs. We use point link. Point link is an elastic link between 2 points where we specify the stiffness. What is the stiffness? If there is an elastomeric bearing, we are giving the stiffness input. To connect the grillage to the support, we use point constraint, or in other programs, you might be using rigid link, where you specify the master slave. In Sophistic, point constraint is the name for the rigid link. Only difference is there is no master slave required in Sophistic. You just click on 2 points. Sophistic is smart enough to decide which one to keep as master, which one to keep as slave. So what I am going to do is, I am going to click on the girder and then connect it to the support. Likewise, connect the girder to the support, and it's done. So you can see that rigid links have been created at these 3 locations. Now these rigid links that I have created along with the supports and the diaphragm need to be copied. So if I am copying, it will be easier for me to copy with a base point. So I will copy with a base point over here. Copying from here, I will go to the blue color placement. This is my support placement P8 at 23 meter. At this location, I will paste at 0,0 reference and then pasted everything. Now here as well, it is the same end diaphragm. Rigid link will be there, but these supports are no more pinned support, so I need to modify these. Sorry. So I will select these 3 pinned supports and click on this modify point command to release px. Once I release px, that means it is free to translate along the x direction. So on the right side I have assigned roller, on the left side I have kept a pinned support. Just to show you, you can see the pinned support with links on the left side. On the right there are rails at the bottom. These rails indicate that the support is free to move along these rails. So it's a roller support on the right. So we have got simply supported condition simulated. Only thing that remains is the intermediate diaphragm. So let me just go to one of the placements. I'll select the diaphragm, copy it from here. I'll go to the middle placement, which is at 12 meter, paste it, and then by double clicking I'll change the property from end diaphragm to intermediate diaphragm and close it. So now I have got the complete PSC composite bridge done with end diaphragm, intermediate diaphragm, supports, and all the girders created. You can see the conceptual view now. It's a complete PSC composite model, and we have got the diaphragms created accordingly. That's it for the geometry and boundary. And the last thing is loads. I'll not take much time in discussing the loads. For loads, just like any other software, to apply loads, we define load cases. So we'll go to load case manager. Under load cases, I have to add few load cases. So I'll show you for crash barrier, for wearing course, for pre-stress. I'll check the action type or load case type as none, because I want the load case types to be defined from construction stages. So I'll change the type to none. Crash barrier, wearing course, and pre-stress, these are the only 3 loads I'm going to show you now and how we can apply. So to see crash barrier, wearing course loads, there are 2 options in Sophistic. One is element load, another one is free load. Free load is basically you can apply a load And just like AutoCAD copy command, you can use copy command to copy the load anywhere you want. But free load will not be helpful in automation. This is an automation model where we want everything to be attached to the element. If I am making changes in the element, the load should also get changed. And for that, we should be using element loads. So we provide element loads and recommend this for the automation models. Let me show you how we can apply these loads. I'll just use area load and select the crash barrier area. For the crash barrier, I'll enter the load intensity, 24 kilonewton per meter square. I'm applying a pressure load. If you want UDL, you can apply it on the edge of the plate as well. So this is the crash barrier pressure load. I'll click on OK. It shows like this, that element load has been applied on this area. If I make any changes in the area, this load will also get revised. Likewise, here is another area where I want to apply the wearing course load. So I'll just click on the area load, select the wearing course area, press enter. This will be under wearing course load case. Load value 1.5 kilonewton per meter square, and I'll click OK. So 1.5 kilonewton per meter square has been applied on the carriageway area. If I have to edit, simply double click and you can modify anything you want to edit, just double click and you can modify it in the CAD interface itself. Any questions so far? So we have used the axis and nothing, sir, because okay, good question, sir. When we are entering the value, I am not defining the negative sign because by default the load is in the gravity direction and we have defined gravity in the negative z direction, so it is acting downwards. For changing the direction, if I use global z, then I'll have to give minus z, minus 24. So this way I have applied the loads over here, and then the pre-stress part. Now pre-stress part, there are quite many challenges with other programs that consultants have faced. Usually when you are applying pre-stress, the length of the tendon is being referenced to the element length. So if there is significant curvature in a box girder, what we observe is the inner tendons are going out and the outer tendons are shorter in length. This problem is tackled in Sophistic using axis. So we don't create tendons with reference to element, we create tendons with reference to an axis. So let me show you how we create the axis and how we create the tendons. Firstly, I'll use the filter and just switch on my CAD geometry. Sorry, I don't need that, there is no CAD. Okay, so I need to create the tendons in my girder. For creating the tendon, we'll go to pre-stressing. Now what happens here is, I'll show you from the top. There are axes already created for girders, and I'll use these axes to create the tendons. There are two ways to create the tendon profile. Either we can have the coordinates specified, or we can have the CAD profile imported to create the whole tendon geometry. As far as coordinate profile input is concerned, you can click on spline to create the spline geometry, or you can have polygon geometry created over here in Sophistic. Now when we are using the spline geometry, it is asking you to select an axis. I'll create the tendon in the mid girder. As you can see, in general, when you ask Sophistic users, they would not be entering all the locations for defining the tendon profile in Sophistic. We just define the control points. So for a composite girder, if there is parabolic, then straight, then parabolic, this is the profile you want, then 5 points are good enough. I'll just show you how we can do that. Either we can enter in terms of ratio, or we can enter in terms of distance. So both options are there. This is for the x, this is x, this is y, this is z. Now for the x, I am having 1, let's say 20% of the length, 1.2. I can add another point. I'll keep it in the center. So I have got 5 points added. From 1 to 1.2, it is parabolic. From 1.2, I have given vertical inclination as 0, so it is perfectly horizontal. If I don't give this, then it will not be a straight profile in the middle. So entering DVS 0 is important at these 3 points, making the profile perfectly straight. So it's a straight profile in between, then parabolic towards the end. I'm entering in terms of ratio. You can enter in terms of distance as well. You just need to select this, change from span station to station, and then you can enter the distances that you need. So let me change this to span station. We have got X, Y and Z over here. Using this X, Y and Z, we are creating the tendon profile. This is the profile. Any questions? Yes, sir. It is with reference to the axis, sir. Axis is located at the girder level, girder top. So it is measured from there itself. Yes, sir. Top of the girder, sir, not top of the slab. So that is why I shifted slab in the negative Z. So I moved it up and kept the girder below. Everything is being measured from top of the girder. So this is the profile I have given. So it is just the profile. It is not the tendon. Now we go to edit tendon. And then we are saying that, okay, I don't want, let's say I don't want tendon for my first 150 mm for the anchorage. So tendon is starting from 0.5 to 23.5. I'll just add 0.15 to this. So it will be 0.65. And from here I can reduce 0.15, making it 23. So 0.15 reduced from both ends makes sure that tendon will not be considered for the anchorage length part. So this is the way we specify the tendons. And once we are done, we also enter in which stage the tendon will be activated, in which stage it will be grouted. Then we choose the code. We say that for Indian standard we just choose with factors, and then we give factors as 1 so that losses will be calculated as per the code. As far as profile is concerned, we have just given 5 points to create the tendon profile. After we are done, I'll show you where we see that, but after we are done exporting the model from here to Sophistic, Sophistic can give us the report where we can have at every 150, 200 or 250, whichever distance we want. At every 150 mm, it can give us the coordinates and the angle for the cable, which we can directly give to draftsman to plot it. So this is the approach which Sophistic adopts. Alternatively, if you are having the CAD profile already calculated at every 150 or 250 mm in your Excel file, you can simply copy paste your Excel file as well with XYZ over here in the table. So both ways it works with Sophistic. I'll click OK. A tendon profile is created. If you want to create another, you can simply copy it as well. So I am copying it horizontally at 0, vertically minus 0.2 meters. And this copied tendon, I'll make some changes in the profile just to make it okay. Let me make it slightly deeper. For the elevation part, I kept it 0.4. Let's take it further below, 0.6, 0.6, and I'll make it 1.2. I'm copying it 0.2 meter upwards, and then it will be at 1 meter distance from the top. This 0.4, let's make it 150 from the top. That should be okay. 150. I just changed the coordinates and we can see the changes at the end. So this is the way we can I just wanted to tell you that we can create a profile and then we can copy for different tendons in the same girder. Once we are done creating tendons in one girder, in any other software, if you have this profile, then for other girders, what you will be doing is you will be again entering the coordinates, creating the tendon profile, but not with Sophistic. You just right click, copy to different axis, you click on the axis. If that axis length is not the same, it will adjust the tendon length. If it's longer, tendon length will get elongated. If it's shorter, tendon length will get shortened as well. Now let's select it, copy to different axis. I click on the third girder, and we have the tendon profiles created in all. Having done that, let me export the model to Sophistic. This is what we see. So this is the model that we have imported over here, And at the top that you are seeing, it's the deck as well. So we can remove the quad elements and we can simply just see the girders. And if you want to see the tendon profile in the girder, you can also see that by choosing to see the only quad cross section, and it will show you how the tendon is passing the cross sections. This is in this format just to visualize. It can be generated for the report format as well. Okay. And one thing I was telling you is the profile of the tendon. So let me show you that as well. So if you see the Sophie Plus report, it's a quite long report that's generated. I'll switch off all the chapters except for tendon. Okay, in tendon, if you see the geometry of the tendon, just have a look at this table. This is good enough for the draftsman to plot the tendon in CAD. So by default, it's giving me at 0.75 distance. This is the distance, and it's giving me the X, Y, and the inclination angle as well. So coordinates and inclination are available for the draftsman to create this in CAD. So even though I just created the tendon profile with 5 points, it is giving me the whole profile for plotting by the draftsman. Okay, now talking about the first thing, the reason why we started the automation. Now this is the model that we have created now with geometry, boundary and permanent loads along with pre-stress. Let's say I have to create this model. This is the tutorial model. Now in this, what's the radius? R 100.645. So let me go to Sophie Plus, and over here what we'll do is we'll go to system. There is girder axis, there is deck axis. I want the deck axis to be curved. I want to make it I get a project where I have a curved skewed bridge. So I'll make it curved by going to horizontal alignment and saying that it's not linear anymore, it's an arc. If it's perfectly curved, we can use arc. If there is a transition, we use clothoid. So for now, using arc is sufficient, and 100.6, right? Roughly I'll enter 100.6. I'll enter it with a minus sign so that it looks exactly same. And since my girders are straight along the x-axis, I'll bring it down so that it is on top of my deck. So angle, I'll make it minus 6.5. Okay, so this looks like that my deck is curved and on top of my girders I have given minus 6.8. Now you can see that the deck is curved, and so the loads which are attached to the element are also curved. I'll show you the loads which are in the post processing as well. For now, in CAD it shows the element loads like this. We have got the geometry curved and we want to give the skew angle to the deck. So this is the girder axis. We'll go to the placements of the girder. How much is the rotation? 6 point. For the deck I gave 6.8, right? Okay, so I'll have to give a skew angle of 6.8. So I'll go to placements. I will rotate Z. Once I have selected the placements, these are getting highlighted. I'll select these placements and give the rotation about local Z as 6.8. For these, I'll give minus 6.8 and click OK. There you go. So once I gave the skew angle for the girders, you can see it's a curved skewed PSC composite bridge. Supports are aligned tangential to the girder. You can look at the tendon length now. The inner tendons are shorter in length and the outer tendon is longer in length. We can see that in the report as well. Let's export it and see the report itself. We go to the model. This is the curved skewed PSC composite model now. I can simply use it to analyze and design. Let's check girder. I'll choose the third and the fifth tendon. Let's compare the third tendon and the fifth tendon. So we can see the elevation and we can see the arc length. So if you look at the arc length, or you can see that in the table as well, just geometry of the tendon. Arc length is 21.993. 21.993 is the total arc length of tendon curve, 21.993. Whereas in tendon number 5, the arc length is 23.473. So this proves that automatically once we make changes in the placements, basically we rotated the placement. The moment we rotated the placement, everything that was inside the placement, that is the diaphragm, the supports, everything got aligned. And once it got rotated, if there was a pier modeled along with pier cap, piles, everything would have been rotated. So it controls the whole geometry. There is no more working with nodes and elements when we are working with axis and placements. Also, to show you the loads, graphics, loads, let me show you the input loads. You can see the loads over here. Crash barrier, let me increase the value further. So 24 kN per meter square is the crash barrier load, wearing course load 1.5 and the pre-stress. So mainly the permanent loads, what we can observe is they are curved in profile. So the moment we modify the geometry, the loads are also getting curved. To summarize, the benefit of automation is nothing but elimination of time that we spend in preparing the model from scratch. If this was the model that you have to create from scratch, placing a node, then the next node for the girder, how much in the x offset, how much in y offset, you calculate, create the nodes, elements, create the geometry. For me, it was a 2 minutes task because I'm just having one axis based model ready. So someone in the discussion mentioned that TPF have, someone has been recruited in TPF recently. Just that reminds me that TPF also has got a similar automation done for PSC composite bridge. They have a single span PSC composite automation done using the axis based approach of Sophistic. They have that ready. These are quite repetitive in nature, these projects in highways. So whatever span length, whatever curvature, whatever skew angle is there, they just pick up that axis based model, make the changes, get the new model generated. That model already has the permanent loads. Unless there is a change like one side footpath, those changes in the loads might be there, so that has to be taken care of. But on a whole, changing the load will hardly take 15-20 minutes. Apart from that, there will not be major change. So your geometry is ready, your pre-stress is done, your loads are done, your boundary conditions are done. Usually for the boundary, we have a standard approach. We just apply on the wooden blocks, give temporary support, shift it to permanent. That is the usual approach. So everything is more or less fixed with such bridges. And since the model is complete, you just make changes in half an hour, export the model to Sophistic, here analyze and design. So that is the workflow, rather than starting from scratch and preparing the model. Live load as well, sir, just to explain. Live load as well, Sophistic users, if you ask, they are using text files. So every live load is written in text. So what happens is, if you refer to the tutorial, you already have the tutorial link. So this tutorial, if you see, sir, there is live load. And where is live load? Moving load, download. What happened? Oh, that has been switched off maybe. Oh, okay. So this is the text file for live load, and Sophistic has created standard text files for 2 lane, 3 lane, 4 lane, 5 lane. All you have to do is copy, paste, and template is the only thing that you have to edit. You don't have to touch anything which is below this. So for class A 70R SV, everything has already been added. All you have to edit is in the, this is the user input. We clearly mentioned that this is the user input. If I have to show you how it looks like in Sophistic, I can do that. But just to help you understand that you have to enter this. Software is storing that what is your access name, reference to which live load will be run, what is your carriageway width, what is the step size of vehicle, what are the number of transverse positions, how many positions you want to generate for class A, for 70R, for SV, what is your speed for centrifugal force calculation, what is the span length for impact factor calculation. You just enter this, copy the whole file, paste it in your project and run it. So that is the approach, and it is fixed for 2, 3, 4, 5, 6. We have standardized these text files. It doesn't take much time to understand, but if you are very new to it, you can simply edit the template, paste it and run it. So that is the way we are tackling it. So just to tell you, sir, I recently mentioned the TPF example. Even the new joinees, rather than trying to understand the text file, just copying the standard files which are available on their server, they just copy it, paste it, edit the parameters and run it. So this is the approach that we have. So live load also does not require, because if you are doing it manually, if you are doing it graphically, insert task, doing it graphically usually consultants don't prefer, because in that case, in any software, it's not just about Sophistic, in any software you have to define the lanes. Okay, for class A this is the eccentricity, these are the lanes, this is let's say it's a 2-lane bridge. So in that case we'll have 2 lanes of class A, 170R on the right, 170R on the left. So 1, 2, 3, 4 lanes would be added. If the number of lanes increase, then cases increase, so the number of lane definition also increases and it takes time. So to avoid that, we have I should say we have recommended, or we have observed that consultants are choosing to go with the text, so we recommend the text file itself. But if you want to do it graphically, you can certainly do it. One advantage with Sophistic, if you are interested in running the live load analysis, Sophistic does the live load analysis using the both the methods. So this is the influence line method. So you can have the influence lines also calculated, which is there in Midas, influence line based method, and Sophistic has the stepping load method as well, which is there in STAD. So it's consultant's choice which method you are convenient, comfortable with, and you use that option for the live load. Stepping load option gives the advantage that extracting the substructure forces becomes easy, because we already have all the live load positions already saved. The text file that we have, it is based on the stepping load approach. It is okay for all types of bridges except for integral, multi-span integral bridges. In that case, maybe there is a middle span and loading the non-consecutive spans becomes the critical case. So for that, we recommend the influence line approach. Except for that, for simply supported, using the stepping load would be the ideal suggestion from Sophistic. So that way we are tackling the live load application. I know one day was, or I should say half day was not sufficient enough to cover everything. It did come to my mind that we can just go with simply supported beam example for a hands-on experience and have the overall understanding of the workflow, but that would be diverting from the agenda of the workshop. So that is why I'm sorry that we couldn't cover the full content in the hands-on experience, but I had to go for the demonstration because 5:30 was limited, and sorry that I have already surpassed that time limit. But hopefully I have given a gist of it. Certainly there might be consultancies or government organizations or educational institutions who would like to see Sophistic curtailed to their applications. So we would be happy. We are in Bangalore itself for coming 4 days. We are here in Bangalore. We'll be happy to meet you in person as well and demonstrate some custom examples. And if time permits, we can have a customized hands-on session as well. Not necessarily in this trip, we just need reasons. So if we see the interest, we'll be happy to come back and conduct the hands-on session to individual organizations as well, if there is a possibility and if there is an interest. I hope that's okay. So that is what I would like to say. And my primary role is, yes, project consultancy, but apart from that, I'm quite often conducting trainings and workshops for new users and companies who have acquired Sophistic. So that is part of my role, apart from doing the consulting work with Sophistic. So I hope to interact with you all soon at your offices, conducting some customized sessions or maybe a hands-on workshop, at least for a full day, so that we can have the full experience. And for any feedback or suggestions, I'd like to share a QR code That's a standard company policy. We are always trying to improve ourselves. Please scan this QR code. Please scan this QR code and share your suggestions. You can also write, if you are interested in something, you can also write it over there. That goes to our headquarters. So please, I request you all to scan this code and fill in the details. It will hardly take a couple of minutes, but it's quite valuable for our team. Okay. There is a request for pricing, sir. Should I share the pricing?
Yeah, why not?
Okay.
No, but you should dual sharing education institutions or you can think, you can discuss with us, you approximate pricing.
Sir, here we have certain pricing already approved from Germany. So this is education pricing, this is commercial license pricing, and there is an approval for additional 10% discount for IABSE workshop promotion. So this has been approved. Shall I present this? Yes. I'll just take 2 more minutes before I share the QR code again. There is a request for understanding the costing of the software. So I'll just share the costing and services slide. I know my colleague Saili over here is a better person to share that, but I'll not take much time changing the person. So let's just have a look at it. Sophistic perpetual licenses, this is the only option that we are pitching. Perpetual meaning it's a lifetime license that we are pitching. And we have 2 packages, premium package and ultimate package. So premium package ranges from 5.5 to 7 and ultimate ranges from 12 to 14. Premium has a limitation on construction stage to 30, whereas ultimate supports unlimited stages. Cable elements are not supported. Cable meaning the external cables, of course internal tendons are supported. Here there is no such limitation, all bridge types are supported, but this one is limited in terms of bridges. Not in terms of bridges, majorly the 30 stage limitation makes it not suitable for balance cantilever or incremental launching or cable stayed bridges. So this is the scope, and Excel automation, pre-stressing in plate elements, detailed finite elements analysis, all these are supported in premium package as well as in ultimate package. Ultimate supports something more, which is RSI. RSI is part of the ultimate package. There is no separate module like other programs. So RSI is included in the ultimate package. Nonlinearity superposition, the nonlinear P delta where I mentioned the buckling analysis, geometric nonlinear and material nonlinear, that is part of the ultimate package itself. The axis based automation is part of ultimate package. Excel automation is supported in both premium as well as ultimate. Axis based automation requires the integration of Revit BIM as well, so it's part of the ultimate package. So this is the major bifurcation of premium and ultimate package, and this is for the commercial license. On the other hand, academic license is quite discounted, and you can see for single user, 5 user bundle, 20 user bundle, the pricing are like this. In academic license, it's a full version license, whereas in commercial license, it's limited to packages, premium or ultimate. So this is overall that we have. And our HQ from Germany has already approved an additional discount. So 10% additional discount will be offered on Sophistic license purchases. That's the IABSE workshop promotion offer, already approved. And certainly if anyone reaches out to Ms. Saili, we will be offering this in addition to whatever offers are currently running. So I believe this will be on top of it, right? Okay. So this has already been approved, and I'll take 1 more minute to discuss about Sophistic's services, because this was also asked during the break time. So how do we learn? So Sophistic's learning, basically we can have the basic and advanced training. Whenever anyone acquires Sophistic, we conduct the basic and advanced training at their office. This usually takes 4 to 5 days, conducting the basic and advanced training. We provide the first project consulting to the private consultants as well as government organizations. We call it consulting because the level of association is like till the values are sent on site, we are associated with that project. So from start to end, we work on that project, giving the confidence. On the other hand, for academic institutions, it's a thesis assistance. So colleges, they choose the students who are having the thesis to be done in Sophistic, let's say 4 or 5 students. They share their thesis topic. We create an example referring to each thesis topic. We demonstrate that example, that's online. We demonstrate that example and students just get that as a reference and the starting point working in Sophistic. So that is the assistance we provide. Of course, we conduct workshops. Learning materials, you already know that you can go to the infraserviceof.com and access all the tutorials. And online help is already there. Just pressing F1, you can get the help manual open on the right. That's with the every software that you'll be using. There are certification courses. You can find the link of certification course on infraserviceof.com itself. You can access from there. And there are webinar links as well. All the webinars of Sophistic that have been conducted in the past are available as a recording and you can access it. Everything is available on infraserviceof.com. YouTube videos are also available there. Now talking about the updates, one major update every year, we keep coming up with updates. Automations. Now automations, if the consultants are preparing themselves, if there is any change in the version, they revise it. If they are acquiring automations from us, that means we have prepared the automation for them, then we are responsible for updating those automations as well as the software is updated. So that is part of our service. For support, there are 2 supports. For technical, you can reach out to us on email, on WhatsApp. I'll be happy to share my number or card. You can reach out to me on my WhatsApp or you can call me, or we are available through email as well. And our Germany support also provides support for India. So we have 2 support teams. One is over here in India who are more off the desk, I would say 15 days off the desk in a month. Whereas German support is fully stationed in the office and they are also responsible for providing support over here in India. Then for sales and license, we have the Sophistic sales team. We have Ms. Saili, who is heading the operations of sales and business marketing. And we have if there is any licensing issue, you have been given the Sophistic, Saili, in the email you have given the Sophistic license, right? Yeah, that license that you have received in email that you can use to activate Sophistic on your own systems as well. So we'll be sharing an email, a detailed email on how to install Sophistic on your computers. You can just follow the steps, install Sophistic, use the same license to activate the software over there. In case you need any help, you can reach out to us, especially Saili, or we can take a TeamViewer session as well to access and help you over there. So, yeah, okay. Yes, sir.
Thank you, Mr. Shishir. As a mark of respect, I request Jay Prasad sir to give a bouquet to Mr. Shishir.
No signal.
God bless you, sir.
Thank you, sir.
Light. And Mr. Shani, Mrs. Shani, our Arvind Salacha will give a bouquet. She was in the back table, always supporting so much. Thank you very much. Of course, you didn't talk anything, and he was there, full mouth. It's good to probably whatever feedback I got here was really encouraging, and even after completion, majority, almost 90% are here. What will happen is after tea break, normally it goes down to about 60-50%. But this indicates people are interested very much. In fact, this is a slightly different software comparatively, and many were asking me whether we can make one more VC. One VC Anyway, we as IABSE, we are conducting a seminar probably July. Sometime in July, about 2 days seminar. In that we, in fact, sir has requested to get somebody overseas, an expert overseas, probably from Japan or Germany. And INJ has got not INJ, IABSE has got a symposium this month and around 20th in Japan. So we can try to filter somebody who is suitable for the Indian conditions, at least 2 persons. With this, I think the software program workshop, which was scheduled from last almost about 2 months, we could successfully complete. One happy note about either IABSE, INJABSE or the IIB. Whenever we conduct these workshops, seminar, or such similar thing, the response was really very, very good. Today, our capacity was only 40, but total registrations, I think it went up to 85. And last time, I think IIB in the KRDCL office, our capacity was only 440 seats, whereas 675 were occupied. Now that clearly shows the interest shown by our engineers. And additionally, my request to all the government engineers, especially the Housing Board, Rajiv Gandhi, KRDCL, or the MI, or the major or medium, whatever, you should curb your pirated versions of this software. Otherwise, what happens? You are doing mistake. For this mistake, you are paying money also. Because why? I myself have found that pirated versions were used. If something goes wrong with your project, something goes wrong with your designs, you will not take responsibility. Finally, the owner is held responsible. So kindly verify from your end whether your consultants already he has started gathering the information, whether these consultants are owning the software. Consultants are supposed to own the software. See, hardly he has shown, hardly it is about 6 to 7 lakhs or 8 lakhs or maybe 10 lakhs for the advanced versions. And you must see your DPR quotations or the PMC quotations. They are not less than 70, 80 lakhs or even 1.5 crore, 2 crores. And serious people, they have already purchased. Serious like either the Nagesh consultant or the Salecha, they have the original. Or even our other consultants. Similarly, kindly insist and refuse, don't take the pirated version. Demand for a ownership from that side. With this, we, in fact, even in the BMRCL, our Srinivas, Chief Engineer Designs, he expressed his very happy method of working out here. He himself is a good designer, personally himself. He himself told that this software is excellent because he can change the parameters easily, either the spanning, girder-wise, except load, I think. Load you can't, live load anyway, it is IRC load, you can't change, or the railway loads you can't change. All other parameters you can change to your will and wish, so that in the same, like the KRDCL is supposed to get about 27 bridge projects cleared, at least about 10 or 15 will be minor changes, like 2-span, 3-span, or girder-wise 4 or 5 girder. So that can be done very easily here. So that one aspect he has also expressed. And in case required, we are also, Arvind Salecha just told that why not we have one more VC, because this is not so much complete. Like he has told whatever possible, but however still to gather more information. Suppose, as he said, some purchases are made by the government or government departments, we can so easily insist him to come back here and provide a lecture. Otherwise also, from ING or IIB, we will be definitely calling, or VC we will be making, so that it will be useful for our engineers here. Hope all of you have really taken some technical things here and gathered more information, much useful to the state, to you, as well as to the general public. And my sincere thanks to you, all of you, on behalf of IABSE. In fact, for your information, the whole thing has been live telecast to even the ING headquarters in Delhi. I think about 70, 80 or about 100 people they have seen. Afternoon, I just called up the secretariat. They said that they have already circulated. I don't know how many people have seen. They will call. Probably in a day or two, they will call. Bahut acha tha, itna acha kabhi bhi. Nowadays, IABSE, they were more busy in the international events. So they are not here. So they will certainly tell. My request to Arvind Salecha, sir, few words from your side, then to him, sir. You matlade, I will matlada. Close matlada.
Well, we are come to the conclusion. I just wanted one information from friends here. Have you benefited, having taken trouble on all this and their impression on you? How much you have benefited? Is it beneficial? Can we have such courses later? Can any one of you from Anantapur answer?
Sir, good evening, sir. Good evening, all. Actually, we have Midas software in our curriculum, but this Sophistic is very interested compared to that Midas, sir. So we request you, sir, please conduct workshop in our institution also.
Good evening to all. By the way, we are organizing 3 days hands-on workshop in our institution from Jawaharlal Nehru Technological University, Anantapur. Also, we have membership with IIB student chapter. From tomorrow onwards, 3 days we have workshop. Please welcome with all of us.
This software link, whatever you have sent, that will be, they can use it for how many days? It will be valid for, what will be the validity? 10 days. Okay, so all of you, you are requested, whatever email you have received, you can please you have 10 days to go through that, practice, whatever doubts you have, you can send email to them so that they can clarify it. Any feedback?
Yeah, so very good evening. I am Professor Ramesh Nayaka from IIT Dharwad. Yeah, so I'm a member of this IABSE. So when it was announced and organized by Jayagopal sir, it was very this is something new which we are not in curriculum and also we are not practicing. So that is where we come forward to organize such kind of the events where we get connected with the industries and also it can be implemented in the curriculum. Meantime, as a practicing engineer, like recently we also had organized such kind of the programs. So there are a lot of outdated things which needs to be updated. So this kind of the program definitely will benefit many of the practicing engineers, academicians, and also industry persons. So thank you so much for this opportunity. Anyway, I got interested in travel way from the Dharwad to here for attending this program. Thank you.
Thank you so much.
See, one thing what I felt is that for a hands-on training, one day is not sufficient. Okay? So that is something we have learned. So next time when we plan, sir, we'll have to go for at least 1.5 to 2 days. We'll have to plan for that. So let's keep that in mind. And instead of 10:30, let us start, say, 9:30, so that we have another 1.5 hour early. So,
Mr. Pratik Jain's, it took half day. And it was equally interesting like him. Really, we really seriously enjoyed the way in which the analysis are done, which we don't do at all. We just leave those things. In fact, Srinivas also told, say, the deflection of girder, we don't take into consideration. Whereas at the bottom, it takes about 25 mm. Deflection of the girder is 80. And for that, his suggestion is make two-level pre-stressing. No, we don't do. We forget, or we are not so serious in those things. Yeah, it will induce unnecessary stresses into the girder, or maybe failures also. Probably some failures must have happened because of such thing. Now, next time, as you suggested, we will go for the full day. 2 days may not be possible, but full day. We will start from the 9 at 10 o'clock. And but it is we never did this hands-on experience from the IABSE. First time, really happy, successful. 1 minute.
thank you. So, a big thank you to BIT for being kind enough. Professor M.U. Ashwath was, the moment we approached him, he just directly brought us to this lab and said, this lab is all yours, you can have it. And that was really very helpful, very nice son. So, thank you to BIT and the entire management for their hosting it, and thank you to IABSE for sponsoring the food and tea, coffee and all. And thank you Shishir and Saheli. They have come here all the way from Mumbai. And actually when we approached Yaman, he said, yes, we are willing to do it. Then we started discussing on the dates, and once we finalized it, they have come up, and it's really nice. And same thing with Pratik. So the reason why I called Pratik is he's a guy who's been using this from a long time. I think almost now 10, 15 years he has been using this. So his feedback and how he is using that is more important. Because today, all of us who are in the industry, we are under pressure, to deliver. Things have to go out very fast. Okay, and to do that, the only way to do it is to have this kind of software where you can do the automation and all. And just like Pratik explained in the morning, for the entire Ahmedabad metro, over 100 span configurations, they were able to, once they crack the thing, that what are the parameters required, what parameters you can change it. Once that is done, then they are able to do it very fast. They were able to do, he said, just 1 hour, one span. I mean, that is just unimaginable. One span, just 1 hour, one span configuration. Next span you want from 28 to 31, just 1 hour. Another 1 hour you are at 34-meter span. I mean, you have changed the radius from straight span to 122, which is the lowest radius possible. 1 hour. I mean, that is really wonderful. So, Pratik is not here, so thank you to Pratik also for that. And thank you all. I mean, whenever we are organizing, as sir said, from ING, IABSE or from IIB, we are really getting a very, very great, overwhelming response. So thank you all audience. Other places, they have the problem of getting people. Here, we are having to tell, no sir, we are houseful. So thank you so much. And I request all the audience to keep supporting us in all our future programs. Thank you so much, sir. Yeah, all of us can please rise for the national anthem, please. Okay. Jana Gana Mana Adhinayak Jaya He Bharat Bhagya Vidhata पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मागे गाहे तव जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे. Thank you all.